webinar. Before we begin today's session, I would like to remind you to turn on your camera and fill the attendance form on the chat room. And good morning, ladies and gentlemen. Welcome to Biomedical Engineering Bridging Medicine and Technology webinar. My name is Giselle, and I will be your master of ceremony for today's session. First of all, let's say thank you to God who has given us guidance, happiness, health, and mercy so we can attend and participate in this special event without any obstacles. And I would like to welcome the Dean of Faculty of Science and Technology, Universitas Airlangga, Professor Dr. Muhammad Yasin, and our speaker, Professor Dr. Muhammad Kahar Osman from Universiti Teknologi Malaysia. Good morning, Professor Kahar and Professor Yasin. And then we also have Professor Tsutomu Terada from Kobe University. And welcome to all lecturers from Biomedical Engineering, Universitas Airlangga, Mr. Riris, Mr. Alfian, Mrs. Osmalina, Mrs. Widianti, and Mr. Fadli. Before we begin our agenda, I would like to invite all participants to sing Indonesia National Anthem, Indonesia Raya, and Hymn Airlangga.
Usnu mana
And now let's hear a welcoming speech by the Dean of Faculty of Science and Technology, Professor Dr. Muhammad Yasin. The time is yours.
Thank you, Miss Natania, as MC in this morning. Can you hear my speak?
Yes, I can hear you,
Okay.
Professor.
Okay. Thank you. Distinguished participants, speakers, lecturers, students, and all guests. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, I say Alhamdulillah that at this time we all in good health and can meet even though virtually. On behalf of all members of Faculty of Science and Technology, Universitas Airlangga, it gives me a great pleasure to extend my sincere and warm welcome to the participant of webinar Biomedical Engineering, Bridging Medicine and Technology being conducted virtually. On this occasion, I would like to thank the keynote speakers in this morning, Professor Kahar Osman from Universiti Teknologi Malaysia, UTM, for his willingness to share his expertise in biomedical engineering. Hopefully, all participants can gain a lot of information and knowledge from Professor Kahar Osman so that it can be benefit for us between UTM and Airlangga. Finally, to the committee members, speakers, moderators, and participants for your kind contribution. I would like to express my gratitude for all the hard work on the success of this webinar. So far, I'm grateful to Allah subhanahu wa ta'ala for his many blessings. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
And before we proceed to the lecture, I would like to invite all participants to turn on your camera and we'll have a photo session with Professor Kahar and Professor Yasin. Okay, does anyone want to turn on their camera? And while we are waiting, I will send the link for the attendance form. Don't forget to fill it after this photo session. Okay, I will lead the photo session. The first slide in 3, 2, 1. One slide in 3, 2, 1. And the third slide in 3, 2, 1. And lastly, the fourth slide in 3, 2, 1. Okay, thank you everyone. Thank you everyone. And now we will start to the lecture, but firstly, I will invite our first moderator for today's webinar, Mr. Alfian Pramudita Putra. He is a lecturer in Biomedical Engineering, Universitas Airlangga, and is actively doing research in biomedical engineering, especially in biomechanics. He is graduated with a master's degree in biomedical engineering from the University of Groningen. Mr. Alfian will lead us on the lecture about past, current, and future of stent fabrication with Professor Dr. Kahar Osman as the speaker. Mr. Alfian, the time is yours.
Thank you, Natanya. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Good morning, Pak Alfian.
It's frozen, yes. Okay.
Can you hear my voice?
Yes, we can hear you.
Good morning to Professor Dr. Kahar Osman. It's nice to meet you, although it's only virtual. Today, I will be the moderator for this session. My name is Alfian Pramudita Putra. I am a junior lecturer in the Biomedical Engineering Study Program at the Department of Physics, Faculty of Science and Technology, Universitas Airlangga. In this session, we will have an honorable keynote speaker, Professor Dr. Kahar Osman, from Universiti Teknologi Malaysia. And here I will read his biography. Professor Dr. Kahar Osman is a professor at the Faculty of Engineering, UTM, Malaysia. He is active in the Computational Fluid Mechanics Group and IGN UTM Cardiovascular Engineering Center. He got his PhD at University of New Hampshire, Durham, USA in 2004. He became a professor in the Faculty of Engineering, UTM, since 2020. He also already published a lot of scientific papers in reputable international journals. He also got a lot of funding for his research. Besides that, he also has some patents and copyright. His research interests include the application of computational fluid dynamics, or CFD, fluid structure interaction, or FSI, and experimental techniques in the study of mechanical and cardiovascular systems, as well as analysis, design, and optimization of cardiovascular devices. He has been practicing computational fluid dynamics for more than 25 years. He started his work in flow modeling in the area of mechanical engineering and moved to the biomedical engineering field 10 years ago. He and his team have produced their own code for computational fluid dynamics modeling for biofluids. He is also currently working on stent development, which is the title of his presentation today about the past, current, and future of stent fabrication. He is currently the chair of the School of Biomedical Engineering and Health Science at the Universiti Teknologi Malaysia. For the presentation, it will last for 90 minutes, and there will be a question and answer after that for 30 minutes. So without any further ado, please, Professor Dr. Kahar Osman, the screen is yours.
Thank you very much, Professor Alfian. Just a very small correction.
Okay.
I'm no longer the chair of the Biomedical Engineering School because I took a leave for my sabbatical, actually. Now I am on my sabbatical leave. It's a less stressful condition. I think Prof. Vidayanti, everyone at my age would like this break so that they can do whatever they cannot do before that. But again, I would like to express my happiness. I'm very honored to be invited by UNIR, Universitas Airlangga. We have had the chat before this, that we have visited each other. I was in UNIR. I didn't remember exactly. I think it was 6-7 years ago, but quite a long time. And again, Prof. Dayanti and also Prof. Alfian, you were here. We are very close together. Before that, can I just share my slide? Just make sure that I will not waste time trying to set it up.
Yeah, sure, Professor.
Okay, I press the share screen and I wait. slides. Give me a second. Give me another second. What do you guys see on your screen now?
Dear Professor,
Wait, do you have this my slides? No,
Uh,
not yet.
no, I think.
not yet, Prof.
Okay. This is embarrassing. Wait. Because we are used to WebEx actually.
Yeah.
Let me do this again. I'm gonna put this down. I'm gonna open up the slides and have it on display. Give me another minute. Wait.
Yeah. Take your time,
Uh,
Professor, no problem.
I know. Okay, let me share. You're supposed to see a PowerPoint screen.
Yes, I can see your PowerPoint. Yes.
Yes, you can
Okay, now
Yes.
see,
Is it-
Prof.
do you see the slides moving?
Yes. Yes, Professor.
Okay, that's good.
Yes,
I'm very sorry.
No problem. I'm listening to your
Are we
issue.
good? Can I start?
Yes, Professor.
Okay, inshallah. Thank you so much. Okay, let me do this again. Thank you very much, Prof. Alfian. Thank you very much, Ms. Nathania, Professor Yasin, and Professor Widayanti for all the invitation. I feel home again. Do you know why I say that I'm home? Because we are not very far apart. I know this is a bit, I can't see all of you, but you can fly to UTM in 2 hours, 20 minutes. I really don't know why they put this driving in 63 hours. I don't know. I just got this from the internet. 63 hours. I don't know whether you really can drive that, but that is okay. We are the fact is that we are not too far apart. By the time difference, about 1 hour. That is good. Those of you who have not visited UTM, you are way down south here. Johor Bahru, very close. You can take the ferry from Batam, which is a very famous way, very popular way for people to come to UTM. I have many students. The last picture is our beautiful university. We have the Grand Mosque, and I would like, what do you guys see on this? Nobody planned this,
Yeah.
right? But we have a very similar architecture. I am surprised. I used to visit Riau a long time ago. They have this lembayung. I don't know whether, yes, we have that. We don't have that lembayung, but I see that a lot in Sumatra, in Riau and so on. But I don't see lembayung at Kunir. I assume that is not common, but the shape of that, see the entrance, the roof, we have been together for like a long time. I doubt that we are so much different. So again, with this in mind, if you don't mind, maybe I will mix my presentation with Malay language and English. I feel more at home in that way. We have that kijang, so kita answer. So whatever you guys have, whatever we have, you guys have. Whatever you have, we have it as well. So I think in the aspect of academic, we should do the same as well. Okay, let's start this talk. I don't know who are attending the talk today. If you are from very first year, you may not know what stent is, but if you are on the higher level, you might have seen one. Your parents may have may have stent implanted in their arteries. Anyway, stent is basically what it is a piece of, it could be a metal, it could be a polymer, it could be silicone for the trachea that you put into your body, and the purpose is for you to open up any blockage or any constrictions. That's basically what stent is. The picture here is a metal stent that is commonly used. Before that, people use the medical practitioners used balloon to open up that constriction. I learned this while I was preparing the lecture. Stent actually is a last name of a person. I think the doctor was called Charles Thomas Stent. I'm not talking to the professor, I'm talking to the students. Can you guess where this doctor came from? Charles Thomas Stent. Anyone? Make a guess. Prof. Alfian, can you guess where the name by the name? Charles Thomas Stent.
From America, USA maybe?
It's a British guy.
Oh, British.
It's a British. I was wondering myself, this stent, because right now, just like the word Google, can you Google that, become a verb? So actually, stent now has evolved into that stage as well. Stent compound was the name of a company. It was used in dentistry actually before. It was actually a compound first, but then it evolved. From Dr. Sorry, it's not Mr. Stent, from Dr. Stent, and then people, they have stent, the one that you see, the actual piece of metal, and finally, as I said, go and Google, so people say now the stenting process, meaning a verb. So stent has evolved after more than 200 years. He had evolved into something that very useful and very beneficial to humankind. I was a visitor at Harapan. I'm sorry, I forgot that. We have the National Heart Institute, but in Indonesia, the one in Jakarta is called Harapan something, right? What is it?
I don't know actually. Maybe
The next,
participant is here now. Maybe
no, the Heart
uh,
Institute. The Heart Institute.
the institute.
Anu, Rumah Sakit Harapan Kitang.
Harapan
Harapan
Kita.
Kita.
Yeah.
Oh, that one.
Yeah,
Thank
I was
you.
there. I was there as well because I was a member. I'm still a member of the UTM IJN Institute Jantung Negara. So we paid a visit. That's where I got that statistic. Whatever we have here is 10 times more in Indonesia. Anyway, this is a better representation of what I mentioned just now. First, it was the balloon. We have the constriction from cholesterol or any other reasons. And then you insert the balloon and the arteries is open up. But then it moved to stent. See, that's the picture. This is, I picked this up. Obviously, this is very common pictures now. You have the plate and then you put insert the stent procedure. So this is the whole purpose is for you to avoid any actual surgery, because this one you don't need any surgery. It's still intrusive, but you put in that long cable and insert that stent or balloon. I also learned this while I was preparing the slides. This was in, can you see that? Where my cursor is?
64.
Yeah, 64. I think none of you was around at that time. I myself wasn't around. So this is how old is this idea was. 1964, it's very old. It's there in the, you can Google that again. The first publication of stent that I could find was development of a safe, simple and effective technique for directly overcoming arteriosclerotic narrowing and occlusion in the arteries of the leg. They didn't use it in the, it's not a coronary yet. It was inserted in the less, I assume it is less lower risk as compared to the coronary. I'm surprised actually they have this online. Maybe somebody made it into PDF and posted it. It's very, there's a lot of things you can find. When I was doing my PhD, I was doing writing some code, and there was an article came from a thesis that I wanted to refer to, and the author was from Japan. I sent him email if he has a PDF of his thesis. Apparently he didn't. So you know what he did? He asked for my address and he sent me the whole thesis. Yes.
Oh,
I was very thankful to him. I really need some information from the thesis. He said, I don't need anymore. He's a very old guy. He's a very old professor. I don't know whether he's still around. He was 2000, in year 2000. He sent me the whole thesis, like, I was very happy. Anyway, we used to work differently for all those young students or young staff. We worked differently before. Anyway, this is some earlier works in stenting. Granzig, this is from Germany, I assume. POBA is a plain old balloon angioplasty. Problem is that the restenosis is about 30% or more, even actually more than that. Therefore, diametric stent, or BMS, I'm going to call that after this, was used. Initially, it was used to together with POBA, but finally they replace the POB, the balloon with the stent itself only. And the bimetallic stent was found to be having lower restenosis rate. I want to talk about fabrication after this, but before that, I'm preparing you for some information on stent, because once we know what is stent, in this case, what is a good stent, then you can appreciate more why do you need a different fabrication technique for a good stent. In principle, stent design, stent is quite complicated actually. Why is it complicated? If you buy a Puma or Reebok shoes, you only put it on your feet, right? But for stent, you can have it in your brain, very small. You can have it in your trachea, maybe slightly bigger. You can have it in your coronary arteries. You can have it in your legs. You can have it in your kidneys. And there's so many areas in the body that you can insert stent. Anywhere that you can also have it in the babies. That's what we started our research in. We started our research in the area of stent. You put it in the babies, in neonate. Therefore, you have to be very flexible. You have to be very creative in ensuring the stents that will fit, that will be suitable for all body parts. The first aim of stent is to reduce stent restenosis. That is very, very important. You must meet this goal to reduce restenosis. Since you put the stent in the body, it has to be biocompatible. That means your body has to be able to accept that. They want it to jeopardize or cause any problems in your body. If it is a metal, it must resist corrosion. And another issue is that it has to be radio opaque, meaning that when you do some X-rays, you should be able to see it. You don't want to put something in your body and you cannot trace it. It's gone. It's there, but you cannot see it, like halimunan, invisible. This stent is not halimunan. It must be there and you must know where is it, because sometimes the stent moves around. So you must be able to trace that. So it must be radio opaque. The stent can also fail if you put it, you move too much. So therefore, I have actually here, I don't know whether you can see it. It is sterilized, so I'm not gonna touch that, but I tell you what, we have an old one. I think I have opened this up a few times. Yeah. Okay, it's very small. We put this in babies actually. I think because we only have 10 of this. I think this is the one that we use for as demonstration, so we can hold it. Can you see that?
Yes, you can see.
Okay. And you can compare that to the size of my thumb. This is an actual stand fabricated in Japan, actually. This is one of our earlier research. This is for babies. You can see that it's very small. It's very thin. I'm going to bring you back to the first slide, second slide. See that? These are called meshes. This mesh, that strut can be as thin as 0.01 millimeter. It's very thin. So it's a very precise. It's a very precise fabrication. Very. We don't have it. We don't have the skill and equipment in Malaysia to come up with the actual stand. But at the end of this presentation, I will share what we plan to do later on. Therefore, this stand, since it is very small, it has to be made of materials with high elastic modulus, high yield strength, and tensile strength, and so on. Because once you put it there, if it fails, if it breaks, then you are in big trouble. For example, coronary stents, you have to withstand. You'll be there for like a long time. Therefore, it must also be able to sustain itself. At the moment, there are three different kinds of stents. First, the one that I've just shown you. People call it bare metallic stents or BMS. This is among the first design that was mentioned in the article. It's very cost effective, very cheap, relatively. But unfortunately, the rate of restenosis is still a bit high. It's not as bad as the balloon, but we could do a lot more to it. Well, high means it's still less than maybe 20%, but we are dealing with lives probably. Therefore, we want something much lower. Therefore, they have developed drug-eluting stents. This is DES. Could be metal, could be polymer. And that drug is supposed to tackle the restenosis issues. And last but not least, this is among the latest one. There are still rooms a lot for it. Anyone can come up with a very safe metal that will be that the body can absorb. You know, that's a very will be capstone research. Could be metal, it could be polymer as well, and still people are debating whether BRS or DES, which one is better. But to me, 20 years from now, it will depend on how people can advance in that area. This is the some pictures that I picked up. And why this is important, the research is important. In 2013, that was 10 years ago, was almost $5 billion. Ini bukan jutawan lagi ya, Pak. Ini bisnis yang sangat besar sebenarnya. $5 billion is 20 billion ringgit. That's a lot of money. And by 2020, they expect it to be almost 6 billion. And now it's 2022, I think it's almost 10 billion actually. We talk about it just now, that yeah, people are getting older. Before the life, what is the life? expectancy in Indonesia now? Umur berapa ya di apa jangka hayat Indonesia? Saya rasa lebih tinggi.
20 years, more than that.
Sorry?
60 to 70 years, maybe.
Saya tak tahu berapa.
Yanti, the Indonesian people
Perhaps.
Life expectancy.
for the long life. I think
Mungkin 70 lebih rasanya.
yeah,
Oh, yeah,
around 70 until 80, Dokter.
Ya,
70 ke 80 kan? Saya rasa
Yes,
kita
yeah.
hampir sama. Kalau dulu mungkin 60. Jadi ramai orang dan dulu di Malaysia retirement 65. Now 60. What is at UNER? Berapa?
For lecturer, I think around 65 and for the
65,
professor
yes.
is 70.
Maknanya umur 65 people are still working hard. You are still a full-time staff. So when you retire, you don't want to retire in in
Bad condition.
Yeah. Therefore, this research of rehab and issues like this, it will grow. It will never stop.
About healthy aging.
Yes, people we want to age healthily, right? Our parents, or at least my parents, my father died long time ago. My mom, she's still alive. She's almost 80 now. She's 80, yeah, 43, 42. Yes, she's 80 this year. Alhamdulillah, she's healthy. She doesn't have stent in her body. She doesn't need stent yet. But many of my friends, my colleagues, they live with this, and some of them, they have stent implanted like 10 years ago. Meaning that you implant this and you expect the life to be extended for like a lot more years. So this is not something like you put in, you do the treatment and you'll be maybe another 2 years. Therefore, if we can have this stent research, first a cheap stent that will work just like a car. Di Malaysia ada Daihatsu Viva. Di Indonesia saya rasa dipanggil Toyota apa ya? Kalau tak silapnya. Betul Toyota yang kecil tu,
Oh.
Toyota yang paling kecil. Saya pernah nampak tu di Indonesia. Kita kalau kereta ada sekecil-kecil dan sesimpel Toyota tersebut ataupun Daihatsu Viva, maksud saya Pro 2 Viva tu di Malaysia, di Indonesia juga, Toyota yang kecil kita juga ada Mercedes yang kecil, kereta yang sama saiz tetapi harganya, kualitinya dan fungsinya, the functions and the performance is much higher. Okay. This is the same goal that we should do for stent. We should have stent. If you don't have much money, maybe you can choose this stent. If you have more money, then you can choose this stent. It will depend on the treatment. But the whole point is that we want as many people as possible to receive the treatment. That is our goal actually. Saya kongsikan hasrat ini pada pelajar saya, because you are the young people. You should, of course, making money, get a lot of patents, sell it. That's one issue. But we should also aim for something that is commonly accessed by everyone. Itu pada saya satu hasrat yang murni dalam research. Kan kita boleh buat kereta Mercedes saja, kan? Tapi yang pakainya, yang boleh membelinya hanya beberapa orang. Tapi kalau kita ada kenderaan yang di pelbagai, daripada yang mahal dengan yang murah, semua orang boleh membeli. Masa saya di US, saya ada anak ramai ya. Saya ada anak 4 orang di US. 3, kemudian saya ditambah seorang, rezekinya lagi seorang. Kalau di US, kalau demam, kita tak pergi ke doktor dulu. Kita akan beli ubatnya dulu. Jadi kita masuk kepada farmasi, dan farmasi tersebut, one aisle, you can have the cheapest PCM, or they call it, di Malaysia dipanggil paracetamol ya.
Yeah.
Yes. You can have the cheapest one and the most expensive one. $3 and $8. Jadi stent ini pada saya mesti juga ada pilihan begitu. Kalau yang bioresorbable BRS maybe mahal, DES mungkin mahal. Tapi kita mahu yang maknanya semua orang mampu untuk mendapat rawatan. What are the materials? Initially very simple, stainless steel 316L. This is one of the strongest material. Good strength, good corrosion rate. This is stainless steel. This is among the original material that was used for vascular stent. What is the problem? The problem is it's not very flexible and it could bend and breaks. And you don't want a broken stent in your body. Therefore, people, researchers are trying very much to improve this. They came up with different material. This is nitinol. What's the good thing about nitinol? Because it has a good shape memory, something that stent doesn't have, stainless steel doesn't have. So once what you do is you compress that, you have the original, and then you press that, and then when you release that, it will go back to the previous shape. So nitinol is a bit more expensive, but it suits the purpose of that flexibility in stent that we want. So now we have two materials that are quite common, stainless steel and also nitinol. The one that I was showing you, this stent just now, this is actually cobalt chromium. It has a very high internal stress, small but it's quite strong. It's a good biocompatibility. It's as good as corrosion resistance as in stainless steel. And again, it has a very good autoradiography properties. So the challenge before was people were trying to keep the bare metallic stent, the BMS, but we are focusing on the new materials. This material will be maybe a bit more expensive, but can cover this. This is a bit less expensive, but it's able to, it's cheaper, but it has some problems. Therefore, people now have more options on stent that they want to use. Why people are looking for better material? Because of this issue. The stent has struts, and the thinner the struts, the better the stent is. You don't want something too thick because that will disturb the flow, and you can promote restenosis. So you don't want something very thick. We are not talking about thick here as in, for a pen, you may say like 0.5 millimeter is already, fine point, very fine. But for stent, we are talking about 0.1, 0.2 millimeter. It's like a very thin. And you know what happens if the metal is very thin? You may lose its strength. Therefore, you need a good design, a good material, and also, since it's very sensitive, the way you fabricate that stent will also play a big role in maintaining all these good stent category requirements that I mentioned just now. So material, fabrication technique, and also the design itself are very important concept for a good stent. And I'm telling you, I've been doing this for like 10 years. We have been focusing on the design. We didn't have much money in the beginning, so we stayed a lot on the computer. We play around with the numerical approach, and then we got more funding. We fabricated our own stent and tested it. You can pick, for the younger students, you can pick one area and stay with it for the next, I don't know, 10 years maybe, just to improve the design of the stent, or just to get a better alloy for the stent, or simply how you can improve the technique of fabrication. Again, remember, you want stent that is, first, you want stent that will open up, that's constriction. I think that's pretty much what's happening. Every stent will do that. But the stent has to be strong. Stent has to be cheap. Stent has to be long lasting, and so on. So this area of stent is very wide, and it's there for everyone to embark on. I was talking to, I think he was if he's not the head, he was the deputy head of the biomedical department. He was a guy from Germany, from Aachen. If you know, anyone knows that place.
Is it Prof. Motagi?
Aachen, yeah, Aachen, Germany. Yeah. He had a PhD in medical and also mechanical. Great guy. I asked him, what are the research that you do? He said, we produce this heart, artificial heart, works excellently, but can you guess how much it costs? It's a €500,000.
Euro.
Yeah. You see, when you have money, you can come up with a very good design. And I asked him, how many did you send? How many did you sell? He said one. But they do a lot of other cheaper equipment as well. My point is that in research, you really have to focus on, when you have more money, you will do this. When you have less money, you will do this. And when you have no money, you should stay on the computer and do a lot of numerical work.
Yeah.
When you cannot travel, when
Okay.
you stay at home during the
Just at
MCO,
home.
when during the MCO, your brain
And
almost
yeah,
dead.
open the
Yes, you
computer.
communicate with your group. Okay, you change the design, you change this, you change that. You see, the point is that you have to be very creative in research. Everyone knows that all countries have their own peak time, low time. A few years ago, I used to have grants, few 100,000 ringgit. Now there are still grants of that amount, but the competition is very high. So you have to change your scope, break it up into a smaller scopes, get less money, but you can still move on. That's the way to go. And this is something that very good. I really appreciate this. You find collaborators. Last time, when we make a proposal, you want to buy this and that, like you want to buy the sun and the moon. And some people got that money. But now the government says, no, if you want to do research, you want to do stent, you cannot purchase a 3 million laser sintering machine. You have to find other companies, other institutions that have this, and you collaborate with them. I like that idea. So you got some money, not as much. You don't have to buy expensive equipment, but you still got your work done. Well, I will share that later on. So that fabrication, so the thinner the strut, but the problem is when you have thin strut, a lot of things changes as well. I'm not saying it's easy for my mechanical colleagues. If you have something of that big, 1 inch by 1 inch, you can see that, and it's very easy to fabricate. But something like 0.01 or 0.1 millimeter, you can't even imagine that. Yeah. You have to use that magnifying glasses and look it up. Why do we need to keep on improving? The BMS has some problem. It cannot stay too long in the body. It will affect the clinical prognosis. Actually, restenosis will actually occur either sooner or later. If it breaks, it can injure the artery and a lot of other issues. As I mentioned before, the rate of stenosis is a bit less than balloon, but still it's a bit high. I know some friends that has the stent replaced. They put in a new stent. And for babies, it's even worse because if the stent breaks, you have to do the operation and take it out, and the muscles, the cells has already grown into the stent, so it's quite complicated. So what people have been trying to do for the BRS, DES maintain the same material, the BRS, the magnesium is one of the early one. It's lightest. It has a good mechanical strength. And it served well in the beginning. Yeah. You can also alter the components, composition of the alloy, and you get a better corrosion rate. For example, you don't want it to corrode or in your body, obviously. And these are just samples of researchers that have embarked on this. People are trying to, if you can get 10% reduction in the 10% improvement in in any field, you are doing good. Another material that people have used is zinc. It has all the good properties, good corrosion. So zinc and magnesium is one of the popular choices actually. On top of zinc and the metal, researchers have also embarked on polymers. This is PLLA, polylactic acid. Is you know, obviously it will not corrode, but you will have the problem of once you change the material, the strength of the stent will also change, obviously. And this is what we are focusing actually. You change the material, you have to go back and sit down and redesign the stent. Ini macam orang tukang jahit, tukang jahit.
Yeah, right.
Yes, tukang jahit. Kalau di Malaysia tu baju kurung tu yang biasa. Kalau baju kurung yang kainnya tebal, dijahitnya begini. Kain baju kurung yang kainnya nipis, dijahit begini.
Tipis.
Yeah. Now very famous in Malaysia. The new trend. Obviously, I learned this from the ladies in my family. Very beautiful, very beautiful clothing, but it's very thin. Obviously, well, not many people will want to wear it. So what they do is they put a different layer inside it. So this is the creativity that people are having. So you put in you combine two cheap materials and you get good product. And it sells like everyone now can buy it. This is again, I mentioned this a few times before. You have to be creative enough and keep trying. I don't know, maybe one day. Again, I was talking about clothing. People have tried, but I never really know what happened to it. Nenas ya, nenas. Saya tak tahu, dulu di Malaysia agak popular kain daripada benang nenas tersebut.
Benang nanas.
Pernah dengar kan? Tapi I don't know what happened. I don't know what happened. Maybe ada, saya tak tahu, mungkin masa pakainya tidak selesa. Tapi the point is that young researchers should embark on this. Keep trying. Whatever you have. Maybe kelapa sawit. Like maybe you don't just throw it away. You put in mix it with many other chemical and become very strong. And so you have to keep on doing this. And this is polymer. Polymer. I'm not a material guy. I have to tell you up front. I'm not a polymer guy. I'm mechanical. But I am. You change the material. You have to change the design, and you even have to change the fabrication method. Don't block your mind like, oh, people only focusing on a metallic stent. No. Polymer is also a better stent in terms of when you put drugs in it, you can, yes. Right now, a colleague of mine, I think you know them, you know her, Dr. Shafika, she's working on ginseng as a coating for the stent. There are a lot of other herbs that you can try. If you have good polymers, very organic maybe, then you will not be harmful to the body. Again, the material, you change the material, you change the fabrication process. Let me talk a bit about the drugs. Again, I'm not a medical doctor, but I think this is quite useful. The drugs is basically the relationship with the stent is that how you put the drugs on the stent. And the best thing is that you want the drugs to be released slowly. So it will be directly related to the composition, to the surface structure of the stent itself. So there are like a lot of issues just for one, you know, this is a bigger one, just for one simple thing. People can join and, you know, I'm close to retirement in less than 4 years actually. I keep telling my students, this research, I don't know whether you can understand this, makan tak habis. Boleh faham Prof? Research ini maknanya dia makan tak habis. The opportunity is endless. Endless. You know, you can keep going. You can try this drug, try this, and keep going. I have samples of drugs. Again, I said I'm not medical practitioner. I don't do drug, but you can even explore different kind of drugs. I just said just now, we are trying on ginseng, which is not available in the Western countries probably. But we Indonesia, we have other herbs. We have our own herbs that we can try on, mix it, coat it, how you do the coating and so on. There's a lot of research in that. A lot, like really a lot. Another issue is because if you spray the drugs, you need to understand that surface structure as well. So stent fabrication will affect all of this. I will start on the fabrication after this. So surface modification is very much related to the performance of the stent and also the way the stent is being manufactured. Why do you need a good surface? Because the adhesion to it, and if you have a very good surface, it can reduce the proliferation of the endothelial cells. You don't want it grows too much, too fast. This is one of the biggest reasons why do you need a good surface coating, because it will affect the drug release. You can, the fabrication technique is able to change the microstructure of the surface of the stent. When we did our first stent, we sent it to Japan because we don't know how to fabricate it. We tried and couldn't find a company locally or in this region. And we sent it to our colleague in Japan, and we got this question of something like there is a number of the surface structure that when they cut using the laser, it's a number that you can cut it according to a certain number, meaning the roughness of the surface. They ask us, you know, what value do you want it to be? We didn't know. We didn't know because we were doing it the first time. But now we know that if you want to spray the drugs, it will be these values and so on. But again, fabrication technique is very important in order to improve the performance of the stent. A smoother surface will reduce the resistance. You can add more See, this is an attempt to include the micro groove actually. All right, there's a bit of information for you to digest. Surface composition also will affect the drug adhesion and also cell adhesion. And it's very crucial. I need about half an hour for the next topic. Okay, now let me do some recap. A stent has to be strong. Sorry, a stent is very thin. It has to be very strong. It's very precise. What else? If you change the material, you will change the strength, of course, and you have to change the design. Different material, different design, even the surface texture will affect the performance in terms of the drugs being used, drug release, and so on. So all of these features have to be taken into account, has to be considered when you fabricate the stent. I shared you all of this so that when you embark on the research, you have to take into account all of this. Some of the early techniques, they have this braiding technique, injection molding, laser cutting. The stent that I showed you just now, that was laser cut. I'm going to talk about 3D printing a bit more. This is EDM and also precision milling. Laser cutting is one of the best for now. Good quality, high processing accuracy. There's a bit of problem because when you use laser, the heat may affect the strength of the stent. That's something that you cannot avoid. I'm going to talk about two techniques actually, laser cutting and 3D printing. This is one of the laser cutting because it's quite popular. It's a very high skill method. 3D printing is, we believe that with accurate knowledge, we can use this technique for future stent. I'm listing you the problem now, but I'll show you some lights. How it can counter the problem that we mentioned. This is the etching. I don't know, not many of you have seen this, but etch is you paint this one area and then you take it out. I only have half an hour left. This is EDM. You have a design and then you cut it. I'm not going to talk too much about that. This is again electroforming, die casting. There you go. At the moment, laser cutting is one of the accepted technique of stent fabrication. You need a very high skill. There are many different kind of lasers. Your physics colleagues who are in lasers, they will help you out. I don't know much about lasers anyway, but CO2, some of the popular lasers that use. The beam quality is very important, and also the technique, short pulse, and so on. The high energy is actually the one that's the problem, because high energy lasers, it will induce thermal energy that is, if you don't control it well, it will be detrimental to the stent. How people overcome this or try to overcome this? Well, the heat is one of the problems. Well, what they tried, they did or they are doing underwater cutting. All right, great ideas. It's too hot, you do it underwater, cools off a bit. If you are into solid mechanics, you will understand that thermal effect or heat stress is very crucial to the strength of the metal. And when you have a very thin strut, it's even more important to really control what you fabricate using that technique. You do it in the open air or underwater, the outcome of the laser cutting will be different. Again, I'm sharing it with you some of the other researchers. The cutting of PLLA and it has some effect on the plasticizer of the polymer. The last one, Tiao et al. See that thin strut will have some problem with sometimes with the laser cutting. This is the drug. Again, this is related to the surface when you do the laser cutting. How the drug, you can spray that, okay, dip that, and so on. I'm going to move to this here. There you go. I'm going to spend about 20 minutes the rest of my lecture for this. Now, today, everyone, in the engineering world, they talk about 3D printing. There is a more glamorous name to it. It's called additive manufacturing. I'm not sure if anyone is familiar with this technique, but additive manufacturing or 3D printing. Well, I think everyone is pretty much involved with 3D printing, right? You can print something like this. This is a phone holder. You can print that, have the drawing, and get the plastic printed out. Small parts. It's very common. So, can we print the stent? That's a challenge now. Can we print the stent? If we can, what will be the outcome? Remember, can we print the stent? Meaning that we have to be able to, the laser has to be able to come out or produce that very fine strut, 0.01 millimeter. So you have this idea of how the stent look like, how precise it has to be. You have the knowledge of this 3D. How do you put this together now? Do you have to change the design if you do a 3D printing? Can you print the same stent that is available, that is produced by laser cutting? Can you just print that and get the same product of the same strength and the same performance? We don't know. Obviously, it will not be the same. Well, it's quite laser sintering comes from powder that you melt and convert that into the product. Laser cutting is you have maybe a cylinder and you cut that and make that into a stent. So it's a two different approach here. And when you do AM or additive manufacturing, you do this layer by layer. Saya rasa semua orang di Indonesia obviously ada banyak kayu jati kan. Kayu jati. Jadi kalau perabot yang mahal, saya andaikan maknanya dari satu pokok itu dipotong kan menjadi satu objek kan. Kalau yang murah maknanya diambil yang serpihan itu dicantum menjadi satu kerusi. Jadi maknanya hasilnya berbeza dan harganya pun tak sama. Adakah kekuatannya sama? Itu kita nak tahu kan. Kalau kita tahu in engineering, if you join, you don't have enough woods, so you join them, it will break here like this. It will break at this point. But if you have one solid wood, you get a better strength. So this is the issues that we have to understand in stent fabrication. Again, you have to know all of those that I mentioned just now, the material, change the material, change the strength, the surface. You may be able to get that thickness that you want, but is the surface the same? Then when you spray, see this, when you spray the drugs, will you get the same result? Or you have to polish, or I don't know. At the moment, there is no stent that is implanted into our bodies. That is the product of 3D printing. Not yet. Nobody believes in 3D printing yet. But can I ask, is 3D printing popular in UNED? Do you know that your friends have been doing this? Ada tak?
Yeah, some of our students also use this.
Yeah, some of us use it.
Yeah. Dr. Widayanti, gigi boleh di print ya?
3D printing, yes. Yeah, some using we made it bioresorbable vascular stent (BVS)
Yes.
using 3D printing also, and some of scaffold for wood.
Yes, it's
Also.
cheap, very cheap, right? I assume. Is it cheaper?
Yes.
Yeah.
Yeah.
So gigi ni boleh diletak, di print saja, masukkan sekali. Sudah pakai boleh dibuang. Besok beli yang lain.
Like
Yeah, that's the point. If we able to do that, then everyone can benefit from the treatment. Kan, you ada satu gigi ni, print saja sudah masuk di situ. Tak perlu kan?
Iya, right.
Kan?
Yeah.
Research patutnya bukan research bukan kepunyaan elit. Dia bukannya okay, ini sahaja yang boleh manfaat daripada research, bukan. Research itu kita yang we crack our head, but the benefit for the people. Kan?
Yeah.
Satu lagi di Malaysia, saya tengok kalau di Malaysia ni yang kalau kaki ada mereka flat fit kan. Kaki tu kalau kalau isteri saya tu dia pergi shoal, shoal tu ada insole. Ya. Di Malaysia kalau kaki yang ada masalah tu, dia ada satu company, itu dia ambil gambar semua dan dia print. Very expensive material. Itu RM700. 700.
RM700.
Itu mahal tu. Mahal.
It is similar with ankle foot, Alfian.
Similar with tu?
Ankle foot.
Yes.
Yeah.
Orthosis,
Yes.
almost same.
Maksud saya,
What kind of material, Prof?
I don't remember.
RM700 tadi.
It's very flexible. It's very flexible, and it's when you step on it, it's a bit elastic. About RM700. You imagine you have a child. You have to replace that every. I don't know, maybe every 6 months. Semua orang ada, yang ada anak kecil kasutnya masih baru lagi, tapi sudah tak boleh digunakan, sudah, it doesn't fit kan. Dibagi kalau ada adiknya, dibagi adiknya. Kalau tak ada, Jadi research untuk medical is a bit challenging in that sense.
Challenging,
Jadi,
that's right. Because many parameters that we must we must pay attention.
Kalau saya
very
dan
strictly.
Dan saya dan Prof Widayanti, gigi itu tidak berubah, itu maknanya 10 tahun. Tapi kalau anak kecil tak boleh. Dia akan lebih besar. Jadi research kita pun kena. Jadi kalau macam kaki tadi tu, if we can 3D print it, which may cost RM20 ataupun I don't know, saya lupa RM1 juta saya ingat saya dalam 300 lebih kurang.
300
300. So maybe kalau I don't know, 10,000 possible. Is it possible? If we put the challenge, you put the price as the challenge, I think it's more interesting, right?
Much more cheaper,
Just more cheaper.
Instead of putting
this innovation,
Yes, it's a motivation for the researchers. You come up with something. Tapi obviously dia macam kereta saya cakap tadi. Of course you still come up with a car. And then yes, it's a different kind of car, but it works. Itu yang penting. Saya baru balik dari betul. Saya baru balik dari Korea. Di Korea tu electric car, Hyundai tu, I'm not sure Hyundai Ioniq. I'm not sure ada tak di Indonesia. Di Malaysia ada sikit aja saya nampak. Like every once in a while you see one. That 100% electric car Ioniq tu di Korea memang people drive as a taxi. Meaning that they benefit from it.
But in dentistry, Prof, it's depend on the degree of severity of tooth decay. So because we are always can use the 3D, but we must do some modification depend on the destruction of the teeth. So for example, if in one case we must preserve the tooth, the root, the root of the teeth, or we just replace the crown of the teeth. So it's quite different.
I know. I have one crown in my mouth. I have one crown. It's 20 years old, but it was it was very expensive. I know that. Masa kita tak ada duit, cabut saja. Tapi bila kalau ada siapa yang ada duit akan letak crown. Sama macam stent. Stent ini maknanya 3D printing is you just print. Dia ada kelebihan. You can, because stent ini dia macam kasut size 7.5. Mungkin 7/1/4 jarang, macam tak ada kan? 7/1/4 tak ada. Tak ada.
Tak ada.
Tak ada. 7,5 mungkin ada. 6,5 mungkin ada. Jadi kalau kita kaki size 7,1/4, kita agak susah.
Okay.
Siapa yang tengok bola, maknanya kasut itu dibuat khas kepada kaki pemain itu. Boleh tak kita buat stand khas untuk pesakit itu? That's the challenge now.
Yeah, but by design.
Customize.
Customize. So yeah.
Customize.
Yes. Customizing the stand. This is very issue. Because if you have the stand, you know, they made it in maybe, I don't know, in Japan, China, India, US, UK. They will, you know, produce it and you buy it off the shelf. This is the size that they produce. 7,5 begitu kan?
Yeah.
Long time ago, or before for babies, they get the stand and they have to, you know, they have to clip it because to fit it into the baby.
To cut, okay.
Yeah, because that obviously we all know that for the mechanical people, we all know that, you know, you cut something, it would not be the same anymore.
Yeah.
Yeah.
Jadi 3D printing does allow you for that flexibility.
Yes, right. Yeah, we can combine maybe any kind of sensor, Prof. Kahar, to make sure the size or the parameters of the heart maybe. Yeah, so we can customize the stents.
Yes.
Yeah.
I got one student who just graduated, very recent, 2 months ago. We don't do coronary. It's very high risk. We do for the trachea. You know, I have this slide after this. For the trachea, you know, here, it's bigger, so it's much easier to fabricate. We did try to use, maybe I should continue. But my point is that customization. Okay, let me finish this slide and I'll go into that. Okay, this is 3 different technologies: stereolithography, and then they call SL. Or SLS, selective laser sintering. This is what that I did. It only uses laser. You have electrospinning also. And I have a friend who is now trying to join materials, which is like different research. You know, one thing, you know, macam baju kan, kain yang tebal dinipis, bukan satu saja. People are trying to improve the product of the 3D printing. Let me finish this first and talk about my research. AM process, additive manufacturing, it could, it's not replacing it yet, but it could. So depending on the process, the manufacturer will have so many advantages. You need new materials because the problem is that with 3D printing, sometimes you don't have the material to print it with. We have cobalt chrome, the one that we use in our lab for testing. We have laser sintering for cobalt chrome, stainless steel, but I'm not sure whether they have all the other materials that is available in laser cutting. This is a very good table, SL, SLS, the traditional, and so on. You can see that a lot of poor here, poor. There are, this meaning that this means that there are a lot more room for research. We don't just abandon that here. You know, of course you have to improve it. I will show you what we did. So in general, 3D printing or additive manufacturing, well, of course, you have to buy the machine. Initial cost will be high, but the printing itself is cheap. You may not have all the materials that is being used in other fabrication technique. Most of the time, you need post-printing like Dr. Widayanti was mentioning. Once you produce that, you have to polish it and do a lot of things. You may not be able to do all the design, but well, this is something that we can learn. The operators, not everyone can operate that. And some of the also issues is that the products in the whole tray, the quality may not be consistent. But you can do customization. We talk about it. Bulk printing. In one plate, you can print many sizes at one time. And I'm concluding this. This is what we did. We actually did. This is tracker stand. We use direct metal laser sintering. We use cobalt chromium. What we did, we picked two designs. One, the one that already available, and we changed the design. And then we do the mechanical testing. This is what we got. This is the one that we currently available. Look at the third column. This is the percentage of improvement. Don't look at it high low, because for radial strength you need high radial strength. Compression ratio you need low. But focus on this one here. The improvement with a different design. I was talking about the customization. With a different design, the improvement can be as the lowest is 10.1 or 9, about 10%, and the highest can go as high as 80%. To me, that is a very good improvement stuff. Just by changing the design, you can get as high as 80% of improvement on the strength of the stent itself. This is I haven't done on the coronary stent yet, because in the arteries it's a bit more complicated. But for trachea, it's air, less, very minimum issue on restenosis, and so on. It's a bigger stent. Actually, this is the actual stent. Our stent is slightly bigger. This is the tracheal stent. Okay, you can see that even the there you go. Even the casing, this is much smaller. We concluded that this 3D printing or additive manufacturing has a lot of room to be improved. And I'm telling you, with the needs that we have of a cost-effective material, product, and so on, this opens up all the rooms for collaboration. You can collaborate on the design, on the material, on the printing itself, on the skills, like everything, on the surface treatment, and so on. That would be my last slide. Thank you so much.
Okay, thank you so much, Professor Kahar, for really nice presentation. Okay, I think we can start for the question and answer session. For all the participants, if you have any questions, you can.
Sorry for.
Excuse me. You can.
Hello.
Yeah.
Sorry.
Yeah. Saya dengar.
Have I asked a question right now?
Yeah, sure.
Okay, sure.
Okay.
Mr. Ready, yeah? Betul.
Yes.
Okay.
I heard about a stance. I heard about the stance is for the athlete that have a atherosclerosis disease. For the atherosclerosis, I don't talk longly, because I focus about the process of the stance. Why BRS is still research.
Why BMS? Why biometric stent is
BRS,
yes.
bioresorbable stents is still researchable. Why not for using immediately like bare metal or wait, yes. And every stent have using an alloy metal, including magnesium and whatever, I forget about that.
Okay.
Can we replace a magnesium alloy with another alloy? Sorry, my English is very messy.
That's fine.
Because
Mas Rary ya, kalau nak cakap bahasa Melayu pun tak ada masalah.
I study Indonesian language.
Boleh, tak ada masalah. Boleh saya ulang. Yang pertama soalannya kenapa biometric stent masih di masih jadi research? Okey.
Masih dalam tahap penelitian lanjut, bukan dalam tahap produksi.
Ia masih menjadi okey. Kenapa BMS? Okey, lagi satu. Dan keduanya?
BRS. Satu lagi perihal ini. Apakah bisa mengganti alloy logam untuk BMS?
Untuk BMS diganti dengan logam yang lain?
Iya.
Okey. Terima kasih Mas Rary. Kalau kita tengok ya, antara tiga-tiga yang ada BMS, DES, there you go. BMS, DES dan BRS yang paling murah ialah BMS. Yang paling mahal ialah BRS. Dan yang paling simple ialah BMS. Jadi BMS ini dia masalahnya satu je BMS. Masalah BMS ni ialah risk stenosisnya agak tinggi. Jadi diletaknya drugs. Saya tidak kongsikan di sini, tapi saya ada lagi satu design. Kita tukar design saja. We didn't change the material. Kita hanya kita gunakan logam yang sama, iaitu cobalt chrome. Kita ubah design. Grup kami cuba fokus sebaik mungkin menjadi pakar, menjadi expert in the design. You give us a size, we can change the design and make it the best. Jadi kami ada satu design lain, BMS, yang mana melalui uji kaji komputer, di dalam komputer dan juga di makmal, belum dimasuk dalam haiwan lagi ya, belum we haven't done the animal testing or clinical testing yet. Benda ni agak rumit ya, dia tak boleh satu. Kami pun tidak ada fundingnya, masih dicari. Jadi uji kaji melalui komputer dan uji kaji melalui makmal, kami mendapati bahawa dengan design yang berbeza, logam yang sama, we can improve the restenosis rate by more than 25%. Kalau kami dapat hasil daripada animal testing, maknanya ini that is like a proof that we get a better design. Maksudnya ia adalah murah, Cuba bayangkan kalau kita boleh guna kaedah 3D print untuk BMS dan kita berhasil mengurangkan restenosis rate, to me is already a sign of achievement in the research. Tapi cabaran untuk 3D print ialah permukaannya ataupun the surface is not as good as the one that I showed you just now. Dia masih memerlukan polishing dan sebagainya. Tetapi doable, masih mempunyai harapan untuk diteruskan. Kemudian tentang logam, logam ni dia ada satu isu yang lebih besar ya. Saya tidak terlibat dengan research tersebut, iaitu isunya ialah biocompatibility. Ini adalah satu isu yang saya rasa yang medical doctor, Dr. Prof. Widayanti dan sebagainya akan faham maksudnya. Biocompatibility ni dia saya tak tahu, I don't know how the experiment is being done. Yes, but you have to test it and make sure that it will not harm your body. Jadi macam saya beritahu tadi, saya adalah tukang jahit. Saya tidak I didn't create a new material for the clothing. I use what is available. Tapi kalau kita boleh buat yang baru, yang lebih baik, that's better. Tapi saya nampak alloy is more feasible than macam stainless steel saja.
Tidak bisa dibuka dulu. Ya, untuk WOS harus menggunakan.
I think it is quite challenging, Professor, for the biocompatibility status related with the composition of the material, because many parameters that we have to pay attention more, very serious. For example, the anti-inflammation also, and then the anti-immunorejection. So for the biocompatibility, if we talk about the biocompatibility, so it is a very huge topic, and then a lot of parameters or indicators related with each function of the organ. So for example, if we create the biomaterial in the ovarium, then we must concern about how the ovarium function can be work normally, so the material cannot disturb the function of the ovarium, for example, like that. So it is also the content, or it is related with the biocompatibility status. So not only testing in the cell line, but also we must capture the performance in the animal, so in vivo or animal study.
Prof. Heri, saya mohon maaf ya, saya ingatkan tadi videonya tidak ada, jadi saya tak perasan tadi.
Mungkin lagi.
Harusnya.
Terima kasih Prof. Heri.
Ini dispon.
Prof. Heri bidangnya apa ya, Prof? Prof. Heri bidangnya apa ya?
Actually, he is master student in biomedical engineering, Prof. Kahar.
Bidangnya, sorry. Tak Prof. Heri yang bertanya tadi, bidangnya apa ya?
Reri, Mas Reri atau Pak Reri ya? Bidangnya apa?
S2 teknik biomedis untuk instrumen medis.
Medical instrumentation.
So biomedical engineering for master degree in Faculty of Science and Technology, Prof.
Instrumentation is a different issue.
Yes, but in instrumentation.
Ada lagi kita boleh Saya harap ada soalan yang membuka ruang kepada collaboration macam yang Dr. Riri beritahu tadi. Maknanya problem yang kita hadapi bersama, kita mulakan research di situ. Kan?
Okay. Maybe for the next one, Dr. Yanti.
Yeah.
Do you have any question for Professor Kahar?
Yeah, actually, I can ask Prof. Kahar by WA, but I like to propose here. So, Prof. Kahar. So the one most important characteristic of stent is not create the restenosis,
Restenosis, yes.
right? Yeah. So that is very, very important. So it is the most important characteristic which needed by clinical standard is the capability not to create restenosis. So do you think the capability of material not to trigger restenosis is depend on the geometrical structure? For example, thickness or structure of strut, or the composition of the material type. So if we want to create the stent which has non-restenosis characteristic, then what we must do? Do we must choose the right type of material or create the proper or the correct geometrical structure? So what I mean here, so which one is more probably dominant to avoid the restenosis event? Yeah, thank you very much.
Terima kasih Prof. Prof. Yanti.
Welcome, Prof.
I'm trying to draw here. Let me find a. Give me 30 seconds. I'm trying to draw some. I'm trying to draw.
Okay, take your time, Prof. Thank you.
Well, in Webex, I'm more familiar with Webex. I know you can draw, but I'm not. I will not try on Zoom. I will waste more time. So what I did, can you guys see this?
Yeah.
Okay.
Yeah,
Please hold on. Okay, I will. Which one, bro?
Yeah. On the top one, I have
Okay.
2 arrows. Okay. On the top.
Can you show again? Okay. Okay.
Top one,
Okay.
I have 2
Clearly.
arrows going straight, right?
Yes. Right.
And then at the bottom one, I have.
So the turbulence. Yeah.
You see
The
this?
turbulence.
Yeah, this. Yeah.
Yes.
This
So
is,
the occlusion, of artery.
This is magnification
Okay.
of a strut.
Okay.
Magnification of a strut.
Yeah.
And so at the top one, from here to here,
Okay.
no problem, no strut, no restenosis.
Yeah, better.
Okay.
No restenosis. But at the bottom, when you have this strut or the strut, depending on the structure, you will have the arrow going here to the here. Attachment.
Yeah.
And you will have this.
Okay.
There's a circle.
Yeah.
This protects in the flow.
Mm-hmm.
Very small within the stent area.
Okay.
The thinner the stent,
tetap nggak bisa.
Smaller is
Ya ini.
circulation.
Oh, lewat itu.
The greater also, yeah,
The thinner
that
the
formation.
yes.
Yeah.
If you can have a very, very thin stent, you can reduce the size of recirculation. Why this recirculation? Why this recirculation is not needed? Because that trigger the restenosis actually. It's like you have a surface, you rub it many times. You can. I'm not expert in this, but you can enjoy it. You can provoke more cells and maybe some injury, and the platelet will come. Restenosis will.
Ya, bikin baru ini.
So therefore, the stent design actually, you cannot avoid it. You cannot avoid stent design. Sorry, you cannot avoid restenosis 100%. But over time, you can delay it as much as possible because that's why we call it rate. And
Bisa ada proof apa dan
the stent to open up the constriction. And obviously, well, I'm not a medical doctor, but I assume you also take medication at the same time.
Yeah.
Alhamdulillah, I'm not a stent patient right now. I don't want to.
No.
Yeah.
Hopefully no.
You will also take medication, right? Yeah. So stent, it's not like a permanent solution. You can, if you can, improve your health, less cholesterol and so on, and this can hold that opening.
Yeah.
Less restenosis, and by the time maybe you don't need that stent to be there at all.
Yeah. Okay.
That is why the research on bioresorbable is very important, because when time you don't need the stent is no longer there.
Okay.
But that is quite challenging because you don't know when you don't need the stent. Right?
Yeah.
Okay.
That's the challenge. Because you don't know. Maybe 1 year. 1 year, I'm better. I don't need the stent anymore. But the stent is still there. So it has a long problem.
Yeah.
But the problem with bioresorbable is sometimes I have read research. Patient with probably diabetic or with heart problem, you take different medication. You have different composition of your blood.
Yes.
So different material will react differently with this. Drugs. Yes.
Yes.
Sometimes you may assume that the magnesium, like Pak Rere was asking, the zinc, maybe it will stay there for 6 months, but for you or myself or others, it may last longer, or maybe shorter. We don't know. That's still a big question that we cannot. Kita tak ada lagi kaedah yang seingat saya, sefaham saya, kita belum ada lagi kaedah. Ambil you punya blood, kita buat test dengan material ini. Okay, your blood with 6 months dia akan resolve. Kita tak ada lagi.
Kita tidak lakukan.
Actually, one of my students is doing the research now. We go to molecular level.
So the blood material interaction. You see the molecular level and cellular level of blood material interaction.
Then you know what is the rate of the absorbable.
Yes.
This is very challenging. Itu perlukan medical doctor, perlukan vet, perlukan engineer, itu saya kata kalau saya cakap lagi sekali ya, ini makan tak habis.
The collaboration.
All of you are much younger than I am. Mungkin lagi 20 tahun you pension, masih belum dapat penyelesaian yang terbaik. Masih lagi kan. Kalau
we must try. We must try, bro. The best ikhtiar.
Betul. Tak, masalahnya if you don't try, you don't
Don't know.
Yes, I.
Kalau kereta ya, saya sebab saya mechanical, saya banyak andaian kereta. Kalau kereta, kalau you tahu kan, tahu karburator?
Ininya sudah betul.
Ya.
Karburator
Ada
dengan
Karburator.
aplikasi
Karburator.
fuel injection ya.
Jadi
Ya.
Dengan fuel injection ni
Inject
has been around for like 30-40 years.
Hmm.
Teknologi dia tidak berubah banyak. Sekarang pergi elektrik, tapi elektrik ni macam lambat lagi kan. Tapi kalau medical kan, we are dealing with life, kan, human life.
Yes, yes, of
Kita nak
course.
masukkan
That's
stent
right.
tu, supaya dia hari ni dia masuk, dia koma,
ini ya itu
dia lagi 1 minggu dia sembuh. Dia dia boleh bangun. Yang dia kereta tak ada kereta lepas.
Ya.
Kalau sakit gigi ya, nanti kita tak mau dia pulang dengan gigi yang sakit lagi. Kita kalau boleh pulang dengan gigi yang hilang.
Yeah.
Jadi
that's correct.
that's the challenge of us, technology and in engineering. How do you do that? Saya masa sakit gigi di US dulu, dia pakai appointment. Jadi tak boleh masuk hari tu. Dia bagi saya pil.
What kind of pill? Painkiller or analgesic?
Very strong one. You makan tu. You makan tu sebab my wisdom tooth kan. You makan tu. You tahu dia sakit tau, tapi you boleh, you can chew without feeling it. It's very strong. The point is that you want an immediate kan. Orang yang masuk dengan constriction, blood dia dah ada 5-6 yang artery yang block kan. Umurnya mungkin tidak panjang. Jadi kita tak boleh customer stent tu tak boleh 1 minggu baru buat dapat stent, tak boleh. Jadi speed of fabrication is also important. You ada stent yang bagus tapi mengambil masa 1 bulan untuk dibuat, patient sudah innalillahi itu.
Memang enggak ada.
Yes.
Jadi there's another challenge. Ini fabrication. You want something that is available in 30 minutes. Kan? Masuk, teknologisnya print dan dipasang. Boleh? Boleh tak? Saya tak tahu. Kan? Gigi tu masuk, kita print, kita boleh bagi balik.
Not so easy like that.
That's a challenge. Teknologi itulah challenge. Itulah challenge. That's the challenge for technology.
Update apanya itu?
Update ini. Not the job of the medical job of the technology.
So that's why we must to make a bridge. So the bridging between technology and
we must
medicine, medical.
We must talk like this.
We must talk. We must sit together, and find the new solutions of each medical problems. I think
the medical doctor has to tell us exactly. Tell them.
Yes.
Saya tahu kawan-kawan saya yang junior ya, dia engineer dan isterinya medical doctor. Saya tahu bahasanya tak sama tu. Bahasanya on the same problem, the language is not the same.
Yes.
But we must make it the same. Itulah challenge.
Ini enggak, maksudnya kita koreksi sesuai sama
yang there is also the model of that Da Vinci. Do you know Da Vinci, Prof? It is the robotic industrial, I think.
Okay.
So they sit together if they want to make some new robot, and then the engineer, also the physician, also the scientists sit together and then discuss about that. So that must be a good model for us too. So I try to do like that.
Yes, we should actually. Yes.
So if I want to make a vascular graft, and then I will invite the thorax and cardiovascular surgeon.
Yes, and also the engineer will tell you what is the best material, what is the simplest way you can attach the graft, right?
Ya, maksudnya tadi sudah.
Oke.
Sudah.
Pak Alfian ada satu yang tanya itu.
Okay,
Yeah,
thank
from
you,
the student
Mrs.
Timothy.
Widianti for the question, and also Prof. Kahar for the answer. We still have 12 minutes for question and answer, and there is one student raised hand in here. Timothy, you can deliver your question directly.
Silakan.
Okay, thank you, Pak Alfian, for the opportunities. So in this chance, I want to ask, but the first is it really worth it to use 3D printing for?
Sekejap, ini Timothy ya. Saya nak
Yes.
agak sebenarnya.
Yes, Professor.
Okay, teruskan.
Is it really worth it to use 3D printing for future method? Consider the beneficial, especially in economical perspective related. When we use 3D printing, we can use like powder and fiber that will produce less leftover instead if we compare it with laser cutting. And my second question is, before Professor said that the SLS is producing the stent using a powder that melt and constructed and form as a stent. What is the difference of quality of metal plate that we carve in cutting machine and the metal that we produce from powder melting and we use it the 3D printing machine? And what actually something that we can do to make the metal make the stand that produced from the 3D printing is better in metal in maybe metal toughness and everything if we compare it with the metal cutting. And is it possible if we consider if some like in my daily life, sometimes I'm seeing like construction of a plane, we use it in 3D printing instead of plate metal now. We use it fiber and coating it with the resin or something. Is it possible for us as biomedical engineering to use that kind of method in human body? Like we make it the construction of the stent consists of fiber instead of making it from the powder, melting it and create a stent, but we use the fiber that we braid it together and make it strong with some materials that can make connect it together. I think that's my question, Professor.
Okay,
Is it something that I need to say it again if it is my voice is not unclear?
I'm sorry ya, Timothy. I wrote down the last two. Yang first one saya terlupa. Selalunya very first question.
We know that 3D printing process is using a lot of time, right, Professor? Is it worth it to use 3D printing in the future?
Okay. I got it. Yes.
Yeah.
Time issues kan?
Yeah, time is money, right? But in the other hand, 3D printing also can cut our costs in materials because powder and fiber is easily flexible to make to other structure than we carve in metal plate. Because when we carve in metal plate, of course we will produce leftover, right? And it actually something that we can use it again, but isn't it? I don't know. I think that's my opinion. So I just want to know Professor perspective on that.
Okay. Thank you so much. It's a very I like the questions, but I would like to answer them all together, but in sub answer as well. The issue is timing, and then the product post production issues of the 3D printing product, and also this fiber issues. The first two, I agree with you. At the moment, 3D printing take like a longer time. For a plate of stent that we printed, about 20 of them, it took them more than 1 day. I think more than 12 hours, sorry. It's not more than 24 hours, but like today, and it stopped, the machine stopped the next day. The very beginning of 3D printing, people use PLA. Ini yang plastik tu ya. Okay. Yang plastik tu dan powder ni tidak digunakan. Tapi kemudian the technology move to powder laser sintering. Recently, people have started bioprinting. What I'm trying to say is that the research in printing itself is quite fast. Saya rasa 3D printer ni long time ago, mula-mula when it first it was introduced, it is not affordable to the common people, right? Betul eh? Not many people can buy it. Now you can buy a very simple 3D printer, not 3D printer yang kertas tu, this 3D printing. You can buy it in Malaysia for 5,000. Meaning it become cheap and affordable to many people. I personally believe that due to the response from the masses and the needs of this 3D printing, the time will be reduced significantly in years to come. Maybe in last 5 years, people will find ways to reduce the time of the production. However, although the research may take a bit more time, as I mentioned just now, in cases of medical, there are some issues when you need immediate response. Gigi sakit, toothache, and people having heart attack and so on. But there are also cases, that's what we started on trachea just now. My example was on trachea. Trachea is not like you can actually wait for a while, meaning that you can put oxygen and put some drugs, and the patient can, well, at least my colleague told me that you can do the treatment for a few days, calm the patient down, and then you can get the stent ready. But some cases, of course, not yet. 3D printing, you need very fast. This one, there sometimes you can wait a few days to print the stent. In conclusion, I'm not seeing all problems can be solved with this customization, but some problem can be solved, especially the one without the life-threatening issues. Yes, I agree with you also, and we also have the problem of product of the 3D printing does not match the strength that is required for the stent. This is doable. This is I agree. We have started actually. One of my colleagues, he graduated. He researched in the heat treatment of the metal product, meaning that you can improve the product by post treatment. Heat treatment, you can do the surface treatment as well to get that to reduce the friction. The heat treatment will increase the structural strength, and last but not least, you can change the design so you can minimize the effect of the heat treatment actually. Just like the one I showed you, the one that we did. That one is like purely, you take it out from the plate of the 3D printer, you test it, and you get different results just by changing the design. So it is doable. And the last part, I'm not even able to read my own writing. Oh, this is the fiber issues. Yeah. This again, I'm not someone from material, but we used to have someone, but she quit and she went to USA for another job. But when she was with us, she explained to me that we could do electro spinning, meaning from the very thin, you come up with the scaffolding.
Nanofiber.
Yes. So the fiber, in my opinion, but obviously you have to change the design. Again,
yeah,
you change the material, you change the fabrication method, you change the design. But this electro spinning is very good, from her word, if you want to put drugs in it.
Yeah.
That one, you are able to release the drugs layer by layer, based on the fabrication of the product itself.
True.
So now every method will have its own advantages and disadvantages. And our challenge is to put all of them together. Thank you so much.
Okay, thank you, Prof. Kahar, for the answer. Unfortunately, we reached the end of our session for first session. If there are still some questions that is not answered yet, maybe we can talk about that later. Thank you so much, Prof. Kahar, for today's session. It's really enlightful for us. I would like to say thank you for your presence today, and I hope the information and the knowledge that you share to us is really beneficial for us. That's all. Okay. I also would like to say sorry if I did some mistakes in conducting this session. Thank you so much. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Thank you very much,
Thank you so
Prof.
much, Prof. Kahar.
Really appreciate it.
Yeah. Okay, Kisah,
Thank you so much, Prof.
start
Kita habis di sini ya.
the following session.
Yes.
Kisah.
Terima kasih semua.
Okay.
Saya okay.
Okay, thank you so much, Professor Kahar, for the amazing lecture. Hopefully, the lecture will help us understand more regarding stent fabrication. And also, we are moving on to the next session, which is another lecture by Professor Tsutomu Terada. And we also have Professor Pak Alfian to lead this session as our moderator. So, Mr. Alfian, the time is yours.
Okay, thank you so much, Giselle. So it's with me again. Assalamualaikum warahmatullahi wabarakatuh. Good morning, all the participants. And I think it's already afternoon in the Japan. And good afternoon to Prof. Tsutomu Terada. It's nice to meet you, although it's only virtual for now. And for the second session, I will be the moderator for the session. My name is Alfian Pramudita Putra. I am a junior lecturer in the Biomedical Engineering Study Program at the Department of Physics, Faculty of Science and Technology, Universitas Airlangga. In this session, we will have honorable keynote speaker, Professor Tsutomu Terada from Kobe University, Japan. And here I will read his biography. So, Prof. Tsutomu Terada is a professor at Graduate School of Engineering, Kobe University, Japan. He received his bachelor degree, master degree, and doctoral degree from Osaka University in 1997, 1999, and 2003, respectively. Professor Terada serves concurrently as executive board member on wearable computer research and development from 2004, honorable visiting visitor in Lancaster University in 2004, and also GST researcher from 2010. He is currently investigating the wearable, ubiquitous, and entertainment computing. Especially, he has applied wearable computing and sensing technologies to various stage performances and actual entertainment systems, including theatrical performances. He is a member of ACM and also IEEE. Maybe if I make a mistake in your biography, I would like to say sorry, Professor. So for this session, Prof. Tsutomu Terada will deliver his presentation for 90 minutes, and there will be a question and answer session after that for 30 minutes. So without any further ado, Professor Tsutomu Terada, the screen is yours.
Okay. So can I start?
Yes, yes, Prof.
Okay. Yeah. I will share the slide. Okay, so thank you so much for introducing me. I'm Tsutomu Terada. So it's a bit difficult to pronounce. So yeah, please call Tom. Okay, so I'm Tsutomu Terada from Kobe University, Japan. And yeah, I'm very happy to join this seminar, webinar. And I'm very happy to have a chance to introduce my research topics to you. So, so I'm afraid that my research area is a bit far from the biomedical itself. So, but yeah, please enjoy my talk. So the title of my talk is Wearable Sensing Applications and the Information Feedbacks. So wearable sensing is very related to the, yeah, actually biomedical engineering. So wearable sensing is not limited to biomedical, so but yeah, healthcare and education and yeah, also including the entertainment area. So I'd like to explain some of them to you. Okay. Okay, so this is a talk on today. So so actually, I don't know the background of you. So so I'd like to explain what is a wearable computing at first, and then so I'd like to use some videos to explain our research topics in our research group. And then in detail, so I'd like to talk about the sensing technologies in wearable computing and the information presentation technologies in wearable computing. So my research principle is to apply the wearable sensing and wearable information presentation technologies to actual field, so including the professional musician and the professional patissier, cook, and so actual professional motorbike races and DJ and yeah, musician, master of ceremony or a handicapped person or something. So actually our system will be used in daily life, actually daily life. So some of our research product will be a commercial product. So I'd like to explain what kind of technology is effective on wearable computing environment. Okay, so at first, yeah, I'd like to explain the wearable computing itself. So wearable mean we can wear the computer. So so the one typical system is this kind of head-mounted display. So this is a Google Glass. So this is a so head-mounted display, including the Android OS, and this kind of system supports human daily life. So there's a Google Glass demo video. So please see together to imagine what kind of daily living will be achieved by using the Google Glass. So what this is the kind of head-mounted display. So by wearing the head-mounted display, so some information is overlaid on actual situation. So this video is not not made by us, so but it is a very good sample to explain the wearable computing.
Meet me in front of Strand Books at 2.
Yeah, so there's a meeting schedule by controlling the system by voice. So, and actually the Google Glass is a commercial product, and so by saying the navigate to the airport or some kind of so please take a photo of this or something. So the Google Glass can take a photo, or the Google Glass navigate me. Okay.
Oh man, really?
So in this situation, the Google Glass navigate the people to the meeting spot, but usually the people uses a train to go there. But yeah, this is information about the subway service suspended. So so the people said that please change the route by walking route. Like this.
Hey there, guy. Hey there, little guy. Sweet. Remind me to buy tickets for Monsieur Gano tonight.
Here, this is the easy way to buy a ticket, buy concert ticket. And so by saying the buying a ticket of the Monsieur Gano.
Where's the music section? Oh, yes, this is it. Is Paul here yet? Huh. Hey, dude, how's it going?
Want to go check out that new place I was telling you about?
Sure.
This truck's really good.
Hey, just a second. Cool.
Good to see you again.
Thanks, man.
Just got a new place, now that's
See you, dude. Whoa, cool. Take a photo of this.
Yeah, so this Google Glass has a camera, so it's very easy to take a photo. So by saying that take a photo of this, and also it's very easy to share the photo to the social network.
Share it to my circles. Oh, I'm running late. Music, stop.
Hi, what's up?
Hey,
Hey.
you want to say something cool?
Yeah, sure. Is that a ukulele?
Yep. Okay, here goes.
That's beautiful.
Okay. So this is just an image video, but actually Google Glass have more functions, so that are explained in the video. So actually this video is about 10 years ago or more. So so there are many types of wearable computing devices now. So this kind of services can be achieved, and yeah, in near future, So most of people wear this kind of computers, and computers helps our daily living. Okay. So, so my research area is wearable computing and ubiquitous computing. And okay, so before talking our research topics in detail, so every year we made a demonstration video from our laboratory. So very short video. So I'd like to show our laboratory's demo video. Yeah, I'm very sorry that this video is explained in Japanese. So, so I'd like to translate. So this is introduction from my so this is a battery-free shoes. So this is a power emitting module. So by power generation using the shock of the step, and so also this device can estimate the foot pressure, and then so generated power can transmit the data to the pressure data to the smartphone. This is just battery free, and but any data can be transmitted. And also, this is another topic. So we made a small copy of you, and so what happened? There are many your faces in the ubiquitous computing environment. So difficult to explain. So what the research is. This is a research on font for head-mounted display. So so for wearable computing environment, it's a very different characteristics of viewing the font. So for example. So if the people is walking, I think the shape of the head-mounted display affect the reading ability of the people. So so what kind of font is suitable for wearable computing is completely different from the normal PC screen. So we investigate also, this glasses recognize the facial expression of the people in front of you. So using this kind of facial this is this is a hair care system. So there's some humidity sensor and a temperature sensor in the heart, and to care the hair. So it's very useful to know the humidity and the temperature in the heart. And this is the stress sensor based so knee joint angle sensor. So using this kind of device, the system can know the angle joint. So it's very important information for the runner, for a long distance runner. to keep the appropriate joint angle while running, and so on. So this is AR augmented reality. So what kind of augmented reality by showing the various information. So this is a smart pencil. This is a force sensor. To get the various kind of information of grip information. So this is a very real. So this is a digital time. So this system can recognize the level of reading ability. So the system can and this is about stress sensor based. This system can estimate the amount of air in the chest. Input interface on a cross. So by using the twinkle, by making twinkles on the cross. So cross it's a very brief, but very short video. But I think everyone in our laboratory have own research scene, and in our laboratory there are about 40 students, and so everyone has own theme about wearable computing or ubiquitous computing, and so this is some of our research topics, and also so I'd like to show on a video. So one of our recent research projects, so named Cyphomatics. So this, I'm sorry, this is also explained in Japanese, but there's an English script on the video, so please read the script. 我々の研究プロジェクトの目的は定時系心理情報学という新たな学問分野を構築することです。近年ですね、こういうウェアラブルデバイス、ヘッドマウントディスプレイとか、こういう VR のゴーグル、AR のゴーグルなんていうウェアラブルデバイスがたくさん出てきています。こういうものを使うとですね、常時こう情報を見る環境っていうのが、当たり前のものになりつつあります。我々はそういった常時情報を見るような環境において情報を見ることが僕らの心身に一体どういう影響を与えるのかということを明らかにしていくということが目的になっています。我々の研究プロジェクトは3つのグループからなっています。まず1つ目のグループは僕自身寺田のグループで、ここはですね情報提示の理論化および、評価のためのセンシング技術について、取り組んでおります。でもう一つのグループが細田グループといいまして、こちらは MRI の計測技術を用いて心理効果のスクリーニングを行うという技術について取り組んでいます。で最後が柳沢グループで、このグループは実践的な応用として特にエンターテインメント技術に注目しまして、こういう情報提示の技術を実際活用していくという取り組みをしております。寺田グループでは情報提示技術の理論化をテーマにしています。具体的にはいくつか成果が上がってまして、例えば虚偽の心拍情報を見ると自分の心拍情報が動いてしまうであったりとか、周辺視野に、 刺激を与えると人間の時間感覚が狂うとかですね、そういったような、理論をたくさん計測評価しています。でそれに加えて、その計測のため評価のためのセンシングデバイスについてもたくさん、ものを作ってまして、例えば鼻の穴の中に温度センサーを入れることによって、呼吸を計測してですね、で呼吸のタイミングから、ストレス状態まで計測するようなセンサーであるとか、あるいはストレッチセンサー、伸び縮みを計測するセンサーを使って、膝関節とかですね、体のモーションを記録していって評価に使うデバイスといったようなものをたくさん開発しております。
私たちのチームでは脳情報を利用して情報提示をされた時の影響の個人差というのを事前スクリーニングする技術というのを開発しています。具体的には高性能な MRI の中で1時間くらいのをじっくり計測して、その後解析することでその人の特性、個人差みたいなものを明らかにします。ただ一つ気をつけなきゃいけないのは、脳は可塑性といって特性とか能力が変われば脳の方も変わるという要素を持っているので、その都度脳を撮像する必要があるっていうこととともにですね、逆に言えば脳を変えることで特性を変えることもできるということができるので、私たちのチームではそこまでをカバーするような研究というのを行っています。私たちのチームはまず VR を利用した際のトレーニングの有効性個人差のスクリーニング技術ということを解明しました。具体的にはですね、視覚介入だったりとかスポーツ介入っていうものを VR を通じて行ったんですけれども、そうするとですね、 VR によってその介入効果がある人とない人というのがきれいに2群に分かれるということが分かりました。でその2群、何が違ったかというのを脳の方から、検証してみたところ、脳構造あるいは脳機能というところに特徴的な違いがあるということが分かりました。つまり事前に脳を計測してその情報を解析することで、その人たちが VR に重要性がある人なのかない人なのかというのをスクリーニングする技術が確立できたということになります。これは特許申請も行っております。
私たちの研究グループでは、視覚的な情報に混入するノイズが観客に与える影響について研究しています。ディスプレイなどの表示装置の一部に故障が起こると、表示される内容が崩れてしまい、見ている人に違和感を与えてしまいます。しかし、情報の表示方法を工夫することで、この違和感を大きく減らすことができます。提示される情報にどのようなノイズが混入すると人は違和感を覚えるのか、また情報の表示方法をどのように変化させると違和感を低減できるのかということについて研究しています。私たちはこの研究を見かけディペンダビリティと呼んでいます。違和感を感じるメカニズムを解明することは、人間が芸術作品を見て美しいと感じるメカニズムの解明にもつながると考えています。
Okay, so so this is one of our recent research topics, the psychology in information presentation in wearable computing environment, and also so it's a bit far from today's talk, but yeah, I'd like to show the very interesting video. So by our based on our research product. So this is an entertainment application for wearable computing. So this is actually used in the professional performers, professional musicians, named Exile. So this is the most famous dance group in Japan. Yeah, so based on our research, so this kind of commercial product will be developed. Yeah, in our so this is some videos to explain explain briefly. So what is my research area? Okay, so from now, I'd like to explain the wearable sensing technology or wearable information presentation technology in detail. So I'd like to say that what are important areas for wearable computing? So one is recognition and logging areas using wearable sensors, and the other is the information presentation techniques using wearable devices. And so at first, I'd like to explain the recognition. So recognition and logging areas using wearable sensors. So basically, this kind of research areas includes context awareness, context-aware services. So we usually call it context-aware. So context-aware means that using the sensors to estimate, to recognize the situation. This kind of services are very wide, from business operation support to the new entertainment services and so on. And also, there's a very important area is a live logging area. So live logging is just recognizing the human context to log the user's life. And it can be applied to preventive medical care. So I'd like to explain this kind of area. So currently, using wearable sensor, so the system can know what you are doing. So this is raw data from the accelerometer. Actually, it's a very common sensor. Even in the accelerometer is in your smartphone or your smartwatch or something. So this is the actual raw data from the smartphone, and this is the data of one of my students, and I asked him, okay, so please buy a drink for me. So please buy a drink in the vending machine. And the system automatically recognizes what the student do. So it's very easy. So at first, the student going down by using stairs and then walking. So this is accelerometer data. So the amplitude of the acceleration is very wide. So because he's walking, and then so he ride a bicycle, and riding a bicycle is a bit explained a bit lower amplitude, so smaller amplitude of acceleration data. So because comparatively it's a very stable situation, so compared with the walking state. And stand and walk and kneel. So this at this timing, in front of the vending machine, the student taking juice or something. So and using this kind of data, this is a very stable situation. The people sit down the chair and reading a book and so on. So only using this kind of acceleration data, so the system can recognize the user behaviors. So this kind of recognition technologies can be used for various kind of applications for wearable computing environment. And so live logging service, there are many commercial products on healthcare system as live logging services. So, for example, there's this kind of this name is Colibri. So this is not our product, but yeah, logging for toothbrushing. So it's a sensor enabled toothbrush, and yeah, the system evaluate the quality of toothbrushing and the everyday toothbrushing, and this kind of data can be transmitted to the doctor. So the doctor can teach how to brush. So by using the accumulated data and so on. So okay, so I skipped that. Okay, so so what kind of live logging service will be needed in future? So I'd like to say that yeah, safety and healthcare support for elderly people is very important research area, important commercial products area. So as you know, yeah, in our country, in Japan, so the ratio of elderly people is increasing and increasing. So it's very important to help the elderly people, and especially sometimes we have a big earthquake or some other kind of disasters. So there are many elderly people living alone. So so we'd like to know this kind of elderly people live healthy or not. So by using the wearable sensor. And so important context to evaluate if the elderly people live healthy or not is yeah, two important contexts are here. So having a meal at the appropriate timing, appropriate number, yeah. And the second is going to toilet at the appropriate timing, or I think the number of going to toilet in a day is a very important information for the living quality. So, but these contexts are a bit difficult to be recognized by usual sensors, including the accelerometers. So, so this kind of context recognition techniques is very important. And to solve this problem, so we developed some new kind of sensors. So 5 senses sensors, the vision, sound, and tactile, and scent, and the taste. So I'd like to say the one of the sensors. So this is a gas sensor. This is a scent sensor. So this is a very small and yeah, necklace type sensors, pendant type sensors, and the 3 gas sensors. So this sensor can recognize the various types of information. So yeah, this is okay. So this is the graph from the sensor from scent sensor, gas sensors. And the gas sensors include the 3 different types of sensors. One is a CO2 sensor, and one is a methane gas sensors, and one is the air contaminant sensors. So air contaminant sensor means the to recognize the dirtiness of the air. And yeah, also the live logging system includes the accelerometers. So motion. So human motion can be recognized by using accelerometer. So, but the scent sensor can recognize the various types of different type of context. So this is a recognized context from scent sensor, and this is a recognized result from accelerometer. So from accelerometer, he's standing, and from scent sensor, he is being indoors. And if the people go out, yeah, I suppose beyond that. So the scent sensor moves something. So And by using machine learning technologies, so this sensor can detect the being outdoors. So by using very simple, very small sensor. And this is a situation having a meal. So when having a meal, the sense sensor moves in specific characteristics, and the system can detect having a meal from the sense sensor. So so the reason why the sense sensor can detect having a meal. So having a meal is a very special situation. So when having a meal, the object food, the object with scent is approaching and disappears. So this is a very special situation. So there are many situations the object with scent is approaching and going away. So it's a very usual situation. So but the object with scent is approaching and then disappears. It's a very specialized situation to having a meal. So the senses can detect having a meal. In the accuracy is about 98%. So it's very accurate to recognize having meal by using the sense sensor. And also, it's very easy to recognize going to the toilet by using the sense sensor. Yeah, it's very easy. The sense sensor drastically changes the value. So especially methane gas sensor, is very sensitive to go to the toilet. So two very important contexts, having a meal and going to the toilet, can be recognized by using the very small sensor, gas sensors. So it's very effective to be elderly people for evaluating the living quality. Okay, and also, so this kind of sense sensor can detect the context related to the health. So smoking context, smoking is very easy to be recognized by using sense sensor. So this kind of sensing technology is very effective. Okay. So so in our research principle, so we apply the very simple sensors to detect the complex context in daily life. And the purpose of life logging is becomes wide, and so one of the purpose of life logging is making our everyday life convenient or improving the quality of life. So so I'd like to explain some research topics of life logging. So one is a smile and laughter logging system. So this system is a glass-based system, and if she make a smile, the system can detect your facial expression. So if you're laughing, so different contexts can be recognized. So what is the purpose of this device? So when you make a smile, I think usually there are many important situations happen in front of you. So, for example, if you meet an important person, so usually we make a smile. And if you find a good thing, good product in a store, so yeah, usually we make a smile. So if the system take a photo when the people make a smile, so this is a very important log of the of daily life. And so how to recognize the facial expression in the system? It's a very simple. Just using the two photo reflector. So this is a kind of simple distance sensor. So just measuring the distance between the glasses and your cheek, or so distance between your eyes and the glasses. So if you change your facial expression, so the distance between the cheek and the glasses changes. So this kind of information can be used to recognize a facial expression. Yeah. So using this kind of information, so the system can detect your facial expression. And by using wearable camera, so this is a kind of live log system can be achieved. So when you smile, so there is an actual situation. When that girl make a smile, so there are many situations. It's a very positive live log. Yeah, like this. And also, so there's another researches for negative pattern. This is a stress logging. So psychological stress logging. So these glasses can detect the stress level of the person. So in medical area, the well-known thing, one well-known thing is the temperature of the top of the nose and the difference of temperature in top of the nose and the body temperature affect is explain the stress level. So this is a so if the difference between the top of the nose temperature and the body temperature increase, the stress level becomes large. So this kind of technologies can be used to estimate the stress level. And also, so our glass-based system, have a very small temperature sensor at this point. And also the body temperature can be recognized, can be measured by using this area. And there are some other sensor, accelerometers and the temperature sensor for recognizing the environmental temperature. So this kind of system all the day, so the system can record the stress level. So we can know what kind of behaviors will be stress on our psychological status. So this kind of application can be developed, and people know so what kind of behaviors will be a stress of you using this glass-shaped device. So this kind of new context recognition technique is very important. And also, very important context is sleeping. And so we developed a smart eye mask for recognizing sleep level. So this is an eye mask shaped device to evaluate the sleep quality. And So actually, I think you may know the sleep level is explained by REM, REM sleeping or non-REM sleeping. And there are many commercial products to estimate the sleep level. And actually the quality, the accuracy of recognizing sleep level in commercial product is quite low. So the actual, very famous sleep tracker has about 60% of recognizing accuracy, recognizing the sleep level. So so in our system, using eye mask, and so this is the image. So non-REM and REM. So REM means REM means rapid eye movement. So it means that in a REM situation, in REM situation, the eye of the person frequently moves. So so if the eye mask can detect the movement directly, so the accuracy of estimating sleep level is very high. And using our sensor data, so non-REM situation is like this, and so like this, so rapid eye movement situation, the system can easily detect the sleep level. So, and just using the photoreflectors, so this is a kind of simple distance sensor, and array-shaped photoreflectors can detect the movement of the eye. So the system can detect the sleep level. And so our system achieved four levels, sleep level in 80% accuracy. It's a much higher than the commercial products. Okay. So so this is a good point. The good point of our device is eye mask shaped device. The in commercial product for sleep tracking is a mat shaped device or the accelerometer based device and so on. So but we'd like to measure the quality of sleeping. For example, in the office, if you have much job, so you have to sleep on your desk or something. So this is a very important to measure this sleep is effective or not or something. So and frequently, we are going to abroad by airplane. So it's a very long trip. And usually frequently we sleep in an airplane for a long time. So, but this kind of sleeping by sitting, I think it's effective or not. So I'd like to know. So so existing commercial device cannot be used in such kind of situations. So, but our device, so we can use we can use all kinds of situations because that's an eye mask shape. So so it's very effective, and it will be a commercial product now. Yeah. Okay. And so this is there's a bit in our introduction video. So but temperature sensors in the nostril.
Yeah.
So this is a very small, so 1 millimeter temperature sensor, and so this is a device for attaching, and we can wear the we can insert the temperature sensor in the nostril. Yeah, he said it looks natural. So this kind of sensors can detect the temperature in the nostril, and this device can recognize many things related to the breathing. So it's very easy to wear, and it's not so obstructing the other behaviors. So we can log this kind of temperature sensor data all the day. And yeah, so there's a bit different temperature in the right hole and left hole. So yeah, actually, I wonder. So why the human has two different holes for the nose? So this is eyes are very important. It's two eyes are very important to recognize the three-dimensional object, and two ears is very important to to recognize the sound in the 3D. So, but I think there's no reason why there are two holes on the nostril on the nose. So but I think there's some reason of so there's main hole. So okay, so it's a bit difficult to explain. So but so this kind of information can be used from the doctor. So this is a specialist of the nostril. The doctor wants to use this device to investigate the reason why there are two holes on our nose. So this kind of information. So this is I think this is the first device to recognize the airflow in the nostril for all the day. So and it's very comfort. So it's very important thing. So various kind of context can be recognized using this airflow data. Yeah, like this. Okay. And also, there's a patterns of new context recognition techniques using active acoustic sensing. So I'd like to show the video. So this is without using accelerometer. So we'd like to know the user movement of how much power they emitted in the muscle or something. So by using the ultrasonic sound, so this kind of context can be recognized. So this is microphone and the speaker is here, and the sound patterns explain the context. So this is a microphone, and this is a speaker, contact speaker and a contact microphone. So and the sound will be transmitted via the skin. So this has a characteristic of the hand movement, or how much power emitted by the muscle. This is just the improvement of the device configuration compared with our previous research. So this is very good construction. So the device cannot be moved. So this is a recognition result. So it's a very accurate. So what the people doing? They are using smartphone. push door like this. So this kind of sound acoustic sensing technique. So we can know the very accurate movement. Using ultrasonic sound. And also, so very convenient sensor, the stretch sensor. So this is a kind of conductive fabric. So this in this way, just the degree of stretching can be recognized. So by using this kind of conductive fabric. So using
30秒くらい撮って、そのスライド中ずっと流しとく。
Okay. So using this kind of conductive fabric, there are many kind of applications can be realized. So one of this is swallowing detection. So I think, as you may know, swallowing disorder is a very big problem for elderly people. So measuring the ability of swallowing is very important for next generations, for in future. So by using this kind of device on the neck, so the people, if people swallowing, so like this, it's very easy to recognize the swallowing context, and the degree of swallowing power or something can be explained in the this kind of sensors. So it's very important thing. Okay, and also, this is also in the introduction video. So this is recognizing the amount of air in the chest. So by using the stretching sensor. So in this way, so by using the stretching sensor, the system can detect the amount of air in the chest. And the application of this is, do you know karaoke? So in Japan, many people play karaoke, and in karaoke system, so usually the pitch information will be presented to the user, and so we can compare the actual pitch and the ground truth of the pitch, and so we can practice the practice of singing, and also our system can present the breathing information. So like this. So this is a professional. This is a breathing information of the professional singers, and in real time, so breathing information. So the amount of air in the chest for the user will be presented. So we can compare how to manage the air in the chest. So by using this kind of system. Like this. So pitch of the singing and so breathing information also can be presented, and we can practice the singing. So by using this kind of system, so it's very useful to improve the quality of singing. Okay. So and this next one is the cannibal pocket. This is a pocket-based device. Pocket means that actual system, so we use the flexible pattern, our system records all of the we can log the event related to the pocket. So this is also, it's very convenient, useful. And also, okay, so next one, this is sleep sensing technology. So actually, this research was done by the student from Airlangga University. So I'm very I'm very happy to introduce. So this is a kind of a wearable stethoscope. So this is a very small contact microphone. And so if we attach the small contact microphone, the various kind of contexts can be recognized by using the sound. So the purpose of this device is to recognize the apnea-related context. So this system can recognize breathing and swallowing, the body movement and oral sound in sleeping state, and very accurate. So these contexts are very related to the apnea detection. So wearing this system, I think the candidate of the apnea can be detected by using our device. So I'd like to show the video. So how to use the system is presented. And this is just a stethoscope. Yeah. And we can attach before sleeping. And after sleeping, so all kind of sound data will be recorded. And so how many events? So the event log, all of the event log can be recognized by using our device. So also heart rate, heartbeats can be recorded. So various kind of information related to health in sleeping can be logged. Yeah, like this. And so by making it commercial products, it's very important to make easy to wear. So how to attach the device is very important. But the recognition accuracy using this kind of device is enough now. Even now, it's very accurate. Sensing can be achieved by using the two different types of microphones at the same time. Yeah. Okay. So Okay, I consume the most of the time time by explaining the sensing technologies, and the other topics are the information presentation technologies. So, but I think there's not so much time. I will something I will skip. Yeah. Okay, so information presentation technique is also very important in wearable computing environment. So as I show in Google Glass video, so using head-mounted display, anytime and anywhere we can see the information from the computer. So various types of psychological effect can be affected by the computer. So so it's very dangerous, and so we should be careful to use the information presentation system for wearable computing environment. So I'd like to explain some of them. So this is the one of our research, our big research result. So this is about the biofeedback system. This is a kind of biofeedback system, and this figure explains the heart rate feedback system, and so we can see the heartbeat waveform, and heart rate, and so on. So in our research, as I show in the false bioinformation feedback. So if the system tell a lie about the bio information, so for example, actually, actual heart rate is about 69. So, but our system can tell a lie. Okay, so your heart rate is 70 and 75 and 80, so become larger and larger. So by seeing this kind of increasing information, the actual heart rate will be improved, will be increased. So by seeing the false information. So, for example, if without any information, the user's heartbeat is like this, it's very stable. And if the false heartbeat data will be presented like this, it's the heart rate increases and increases. So by seeing this kind of information, the controlled bioinformation, so the actual heartbeat will be increased. So by seeing the false biofeedback data, so this kind of behaviors is very important. It's very dangerous, and so but if we utilize this kind of information presentation technique in a good way, so it's very effective. So for example, if the people has a disease and he has a high body temperature. So, but if the system shows the body temperature decreasing and decreasing, so the actual body temperature will be decreased by seeing the information. So just seeing the information, your bio data can be controlled by presenting the information from wearable computing. So this kind of psychological effect, this is a kind of placebo effect. So this is I think this will make a new research area of wearable computing, biofeedback system, and so on. So I'd like to skip. Okay, so okay, and also in the psychological area, there is a priming effect. So for example, I'd like to show an example. so there's a wearable computing head-mounted display with camera. And we gather so we performed the experiment by gathering the more than 100 people. And we asked the participants of the experiment, okay, so please take a photo freely by using the wearable computing device. And the people can see the desktop. So this is a kind of the smartphone screen in head-mounted display. So there are several kind of applications like map application and camera application and timer application and the photo gallery application. And so by using camera application, so the people take a photo freely. And actually, in this experiment, we divided the participants into 3 groups. And so what is the difference among groups? So just icon image of the camera application. So this is a building types icon, and this is a flower types icon. This is a car icon. So this is a very trivial difference. Just an image of the icon. So, but the result is very clear. So the people with building icon, so take many building photos. And with flower icon, so these people take nature photos so much, and also with car icon. So there are many photos compared with other groups. So big kind of photos can be taken. So just it's a very simple, very trivial. Just seeing the camera icon, camera application icon. So the behaviors can be controlled by seeing the photos, seeing the icon image. So I think it's a very danger. So so this kind of effect cannot be happened in smartphone. So we performed this the same kind of experiment using smartphone. So but this kind of effect does not happen. So wearing the device and all information is anytime, every time in front of you. I think this kind of priming effect can be happened. So so wearable computing is information presentation in wearable computing is very danger and very effective and very important things to be investigated. Okay, so this kind of I will skip. Okay, so this is a very important, very interesting result. So this is blinking 3 icons, and okay, so please select one of them. Please select one of them, and so this is a very interesting result. So people often choose a button that blinks at a frequency closer to their heart rate. So if the heart rate is 60 per minute, so and the buttons also blinks 60. So the people choose this, and so synchronous between the GUI, between the interface and the biorhythm. So we can, we may choose the related bio-related synchronization information. So using this kind of technique, I think you can make the people select the intended button. So like this. So this kind of information is very important. Okay. So I'd like to skip them. Sorry, I'd like to skip some of them. So at last, so I'd like to discuss about the new technology acceptability. So for as I introduced, so there are many new technologies, especially in wearable computing environment. New technology will be developed. So I'd like to explain the acceptability of new technology by using the example of sports training. And so in this slide, this is an example of sport training of badminton. Okay, so okay, conventionally, I think so there are so much technologies. So there's not so much technologies in badminton training. So conventionally, basic training methods have been uniform. So one training method. And people A perform the training method X, and he's becomes a sports. Okay, like this, and actually, each people have the acceptability of the training method. So if the people A, B, and C have a same possibility, same capability of badminton. So, but the difference in acceptability of the specific methods, specific training method, I think the result is completely different. So, so conventionally, the people who has high acceptability of traditional training method achieved a good result. So, but I think, people B and C, if the people B and C has the same potential for badminton. So, but there's a low acceptability of training method X. So I think they are not familiar to be trained. So this is a conventional situation. And but in future, now, so using the virtual reality technology or augmented reality technology, sensing technology can make a new types of training methods. So so there are many training method X and training method Y and training method Z. So there are many types of training method can be developed, I think. So so each person has an acceptability for each training method. So for example, the people A has much now acceptability to the training method X, and it's a no acceptability for training method Y, and very good acceptability for training method Z. So so in this kind of situation, so important things is how to choose the training method. Yeah. And also, for example, there are many in future. There's many new training methods. So, for example, actually, we developed a new training system for badminton. So, actually, by using the virtual reality. So, in this training method, the people doesn't use any shuttle, actual badminton equipments. So just but in virtual reality area, make a training of badminton. So do you know? Do you think about it? So this is effective or not? By using virtual reality training is effective for improving the capability of actual badminton. So so if the so sportsman so I'd like to introduce the this kind of new training method can be available for you. So, but yeah, I think it's very dangerous to try a completely new training method. It's a very I don't know it's effective or not. So so training consumed 5 months or 6 months. So if after 6 months the training method Y is not effective for you, so yeah, I think it's so bad. So so finally, yeah, usually the people choose the traditional training method because the new training method, we don't know if the new training method is effective or not. So actually, yeah, we make an experiment, the effectiveness of the virtual reality-based badminton training. So in the experiment, so we performed the skill test, badminton skill test in using actual field and the actual badminton set, and then for 4 weeks. So 4 weeks, the people train the badminton only in virtual reality, only using virtual reality, and then so in also in actual situation, so we test the badminton skill in the actual field. So and I think 40 people participate the experiment, and so this is a very clear result. This is a change rate means how much improved the actual badminton skill, and so this is clearly two different mountains. And one is high acceptability persons. So this means it's very effective to improve the badminton skill by only using the virtual reality. So this kind of people can use the virtual reality training, and also there are many people there's no acceptability of the virtual reality training. There's no change, no improvement of badminton skill. So by training in virtual reality, so there are different types of the acceptabilities. So so yeah, we can prove. So there are many training methods, and there are different types of acceptability for each person. So so yeah, actually we'd like to propagate the new training methods. So we need the acceptability check phase. So this is actually long-term training. If the long-term training will be needed to know the acceptability for the training method, I think usually people does not accept using the new training method. So, but it's a very small term, or just so beforehand, if the acceptability, we can know the acceptability for each training method, so we can choose the best suited to you. Yeah, and so how to check the acceptability of virtual reality? So we can use the brain information. So it's very good. It's very novel research to estimate the acceptability of the virtual reality can be recognized by using the MRI data. So the high acceptability, high virtual reality acceptability people has a large volume in this part. So so by applying the MRI once, So this kind of virtual reality acceptability can be estimated. So by using the brain data. So this is a very important things to accept new technology. I think this kind of screening technology is very important. So for screening, our proposal is to use the brain information to check the acceptability. And also, our research group tested various kind of acceptabilities using brain structure, and there are many research results can be achieved, and brain information can be used to check the acceptability. Okay, so it's very brief and so wide variety of topics. So I'm sorry, it's a very unstructured presentation. So, but it's a conclusion. So today I talked about the wearable sensing and wearable information presentation technologies. So I think, I believe that these are very important research areas for future human daily living. So computers will know almost all of your information by wearable sensing. In futures, I think the computers should know almost all of your context you want to know. So so this kind of technology should be used correctly. And also wearable information presentation will may control your body and mind. So so it's very important to investigate what kind of effect on body and mind by seeing the information from the wearable devices. Okay, so that's all. Thank you so much.
Okay, thank you so much, Professor Terada. It's really nice presentation. Which is for me it's quite really related with our daily life, because it's almost we use that kind of technology for daily living. So for the next session, we have a question and answer session. You can type your question in the chat room, or maybe you can raise your hand to ask your question directly to Prof. Terada. Oh, okay. We have one participant here, Catherine and Hafiz. Okay, maybe first, Catherine first. You can deliver your question.
Thank you, Pak Alfian. Thank you for the interesting topic, Prof. Terada. I would like to introduce myself first. My name is Catherine, master degree student in Biomedical Engineering, Universitas Airlangga. I would like to inquire about the possibility of wearable sensor in VR imaging. I think VR can play an important role in medical field. For example, a simulation for medical action in surgery. But however, we know that most of VR only use kind of handle to provide feedback on the system. So that prospective doctor will find it's difficult to get the impression in performing surgical techniques. Based on your experience, it's possible to use wearable sensor to display our hand movement and produce smoother feedback, especially in real time, so that we can see our hand directly and we can operating surgery directly to the patient like in the simulation. Thank you.
Okay. So in the surgery area, so wearable computing techniques will be applied in the, and actually we perform the hand movement recognition. So without attaching the sensor to the fingers. So as I show in the ultrasonic based gesture recognition techniques. So just using the some kind of sensors in your wrist, the finger movement can be recognized by using the wearable sensors. So so professional doctors' behaviors can be recognized and recorded by using the wearable sensor. So so in surgery area, I think the professional movement can be used to the so okay, so what is the main main question from you is so how to apply this kind of technique for simulating the surgery condition? So okay, so this kind of technique and so user movement of the is various kind of human information can be recognized by the computer, and so this kind of situation can be applied to the virtual reality content and augmented reality content. So there's a many types of surgery simulation system by using the wearable sensor, and I think that will be commercial product to surgery virtual surgery simulator. So by using wearable sensors to detect the finger movement and eye tracking data. So I think in a few years, so this kind of simulation system can be commercial product, I think. So is it a correct answer to you?
Yeah, I think I get the answer. That will be possible in there if we use finger sensor in there.
Yeah.
But how about the imaging? Is there have the
I think as you may know, so there's a MRI technology and CT technology and echo technology and so on. So now there's a very big equipment. So but actually in our research group, so we'd like to develop the wearable CT or wearable MRI or something. So so this kind of techniques to make the sensor system small. So the inside of the body image is easily can be detected by the wearable sensor. So for example, it's there's I think next year there will be a commercial product to detect when you want to go to the toilet. So the system is a very small device, but so wearable echo sensor, and yes, using this system, the sensors scan inside of your body, and the smartphone application tell. So after 30 minutes later, you want to go to the toilet. So this kind of information can be sensed in the wearable sensor. So it's a very usual things to know the inside of the body to make a simulation or something. Yeah.
Thank you for your explanation, Professor.
Thank you.
Thank you, Catherine and Prof. Terada. And we can carry on to the next question, maybe from M. Hafiz. You can deliver your question.
Okay, thank you very much for the opportunity given to me, Mr. Alfian, and thank you very much, Professor Terada, for the amazing lecture. As we know, at the Biomedical Engineering right now, I am an undergraduate student from Biomedical Engineering in Airlangga University. We know that this wearable technology that we make must be make people can prevent their bodies from getting disease. However, in Indonesia, as there is a research about the wearable technology, doesn't have a good prospect like that. As you know, there is a smartwatch in Indonesia, some brand, they out a product of smartwatch and fitness band. I remember that it's not have a good prospect because it's expensive, and if you in Indonesia tell expensive, and they gonna say maybe just buy a phone, not to buy the smartwatch or anything else. So the first question is, there is a suggestion from you, Professor Terada. How can we create a wearable technology that can be a preventive device for someone to get a disease, but it affordable for all people? It's not too expensive. It's maybe for the tools that we create. It must be more cheaper than the others, or maybe anything about the suggestion of it. And then the second question is maybe a suggestion too, because several days ago until right now, me and several of my friend is doing a research. This research is to create a device to detect a person level of dehydration as a preventive against chronic kidney failure. We use this one. Sorry.
Okay.
Yeah, it's TCS 3200 that we use to be a color sensor to detect the color of the urine. But the problem is the noise of the sensor is too much detecting the color of the water. It's really big. So any suggestion from you about this device, or maybe we must change, or any sensor that you can suggest to us? That's all of the question. Thank you very much, Professor Terada.
Okay, thank you so much. So yeah, as you developed your own device, I think the sensor is originally it's a sensor is a very cheap. So so as you show, as I show, most of the sensor technologies we use a very cheap sensors to detect a complex context. So this is a gap. Yeah, this is a gap of the commercial product sensors and our developed sensors in the price. So but I think I don't need to care for the price. I think the price will be decreased. So by propagating getting a sensors. But one thing is that so I think in near future I think we will construct your own wearable computers. So by own, so we can buy some parts to construct your own wearable computers. So this is for example, we usually use a notebook, laptop or something. So, but in wearable computing area, there's various types of displaying device, and there are various types of input device and so on. So, so in wearable computing environments, we can choose the input device and the output device and sensors at your own needs. So so I think by coming such kind of situation, I think you can choose the cheaper sensors and the cheaper equipment. So at least you satisfying your own needs. And I think in this kind of wearable computing environment, you can construct your own personal computing structure. So I think their price problem will be dissolved, I think. So, but yeah, I don't know. But one of my principle is to construct wearable sensors with very cheap sensors, very simple sensors to recognize the complex context. Okay, and okay, this is for the second question. So I'd like to know. So what kind of context you want to recognize by color sensor?
Yeah, the color of the urine. Color of the urine, and we detect it. and then that's as we read on the journal, it can be declare someone a hydration level. It's maybe dehydration or hyperhydration, and then it's gonna be a tool that can preventive them to the one of the most killer diseases. We know that chronic kidney failure. That's one of our concern.
Okay, so if I will develop this kind of sensors, I think I will try several combination of the sensors, and so one promising example is active sensing. So for example, if you use a color sensor, I think it's okay to use color sensor, but in addition to color sensor, so you can use the specific color LED to actively light at the target. And for example, 3 different color LED, so green and blue and red. And in turn, if the so red is lighting, and then the 1 second later, green is lighting, and then 1 second later, blue is lighting, and so on. So this kind of changing the environment. So actively you can change the environment by using the LED, and then so all of the time series data of the color sensor. I think it can improve the recognition result. So one way is active sensing is a very promising technology to improve the accuracy of the recognition. So actually I cannot say a good thing, but I hope you make a success.
Thank you very much, Professor Terada. Thank you very much for your service.
Thank you.
Okay, we can continue to the next question. Maybe from Khalid. You can deliver your question, Khalid. We cannot hear your voice, actually.
I cannot hear.
Or maybe you can write in the chat room if it's not possible for you to speak. We still cannot hear you yet. Okay. Or maybe you can write it in the chat room, Khalid.
Okay, do you hear me now?
Okay, we can hear your voice. Can you
hear me now?
Question? Yes.
Yeah. Thank you so much. Thank you, Prof. Terada, for the amazing presentation. Really, we enjoy and we take fun with the active presentation. So we was waiting for all the amazing notes that we take it. I am interested about the sensor that is stimulated about the brain, and take also the pictures, as we said in your in one of your projects, that you take a video and use it and analyze it. So how can we take the video from outside and make it stimulated with the brain? We know that like a bionic eyes, we know that the bionic eyes has implanted in the brain, but can we make as stimulated without any surgery, but with outside, like using any sensor that have related to the visual birth?
So do you mean the how to imagine how to how to create the image. So image of the brain structure.
No, how can we take a video from outside and stimulate it with the brain, like the bionic eyes? Yeah, is there a sensor especially for that? Is there a programming? Can we simulate it? Is there something can we put it in the surface of the brain from outside without any surgery to take the signal of the brain and also stimulate it with the computer?
Okay, so I'm sorry, in detail I cannot understand what is the what is the
Can I make a small explanation? In your project, we take a video from a camera, right?
Yeah. So okay. So what kind of project you mean?
I think the first one that you use a video from outside from the camera from classes. Yes.
Google lens, I think that one.
Camera.
Yes. That one. Yes.
Okay.
Yeah, you take a video from outside, right? And you try to recognize the signal. So how can I use this project, but I stimulate it with the signal of the brain?
Yeah. So
actually use it with the people have poor vision and the people that blind cannot see.
Okay, I see.
Clearly.
Yeah. I think in this system, just we use a wearable camera, so to take the movie from the. So this is just a setting of only recognizing the stress level, and actually, so if you want to know the situation of high psychological stress, so you must wear the wearable camera to record the video. So just attaching a small wearable camera in another side other side to the sensors. So you can record all of the POV video so by using the wearable camera. And then, so using timestamps, this kind of analysis application can be unified recorded video data and sensor data. Yeah. So sorry, I didn't understand what the question.
Thank you so much, Prof.
Thank you.
We can carry on to the next question. Thank you from Sakra.
Okay, thank you for the opportunity, Mr. Alfian. I'm Shakra Abdullah, an undergraduate student from Biomedical Engineering Universitas Airlangga, and I'm very interested in the topic of this wearable base sensor explained by Prof. Terada, because I think it can help healthcare a lot, and because it's easiness to use. However, I think with the application that can be used to collect health-related data, and I think this data is quite personal. I think my concern is about data security, because there are possibility that some devices should be connected to the internet, and what should we do to make our data safe and doesn't get into the wrong hands? Thank you.
Yeah, I think it's very important topics. And I'm not a specialist for security and privacy issues. And so there are many researchers to investigate how to keep the privacy for this kind of data. So as you said, using this kind of technologies, so compared with now the current situation, I think so much private data will be generated by wearable sensors. So how to manage the data is very important. But I think usual people cannot know the value of the raw biosensor data. So it's very important to educate so what kind of information can be recognized by using this raw biosensor data. And so there are two different approaches to keep the security and privacy. One is centralized approach. So there will be a bank for the biomedical data. So every people can transmit every people should transmit the privacy data to the biomedical data bank. And the bank has a very strong security and communicate with the companies to use the privacy data. So this is very easy for the general people. So, but I think it's a bit danger to centralize the privacy data into one company or one bank, and so. And the other approach is to keep all of the privacy data in your wearable computer. And if a kind of service needs some privacy data every time, so we should evaluate the value of sending the privacy information to the company. So I think it's a very clear way to keep the privacy data in your wearable computer. So, but I think also general people cannot evaluate the value of the privacy data. So, what kind of data can be transmitted to the private company, or it shouldn't send this kind of data or so on. So it's very difficult to distinguish. So both ways are also having some problems. So in Japan, for example, in Japan, there are two different big researchers groups to fight. Two groups fight each other, and I don't know which approaches we will apply in near future. So, but there are two different kind of methods, and both are. I think both approaches have very good, and so people investigate the best way to keep the privacy. Okay.
Okay, I think this already explained a lot about my curiosity. Thank you, Prof. Terada.
Thank you.
I think we are already almost at the end of the session. Maybe this is the last question from Indira. You can deliver your answer to your question, Indira.
Thank you so much, Mr. Alfian, and thank you so much for such a wonderful presentation, Professor Terada. I actually very interested at how your research is regarding how to create a quantitative data from a qualitative perspective like psychology. And I think this is a very it is one of my curiosity. Could we manipulate how people choices by using a technology that could detect their psychological behavior at how they're making their choices? Thank you so much, Professor Terada.
Thank you so much. Okay, it's very it's very difficult. Actually, I skipped some slides, and so everyone has the acceptability to the psychological effects, and once we take in our research approach, once we scan the brain of yourself, I think for each psychological effect, so we can calculate the acceptability or plurality of the for the psychological effect. So so we can get a series of the acceptabilities for each psychological effect. So based on this data, you can choose the appropriate psychological effects or appropriate displaying method for wearable computer. And yeah, especially so as I said, the wearable computing is very flexible. So we can choose one of the input devices and yeah, one of the displaying device and so on. So so this kind of familiarity or acceptability can be calculated by using the information technologies. So so using this kind of technology, the system can recommend so what kind of technologies is suited to you. So but yeah, based on this kind of recommendation, so I think you can choose the technology and the devices and as you like and so on. Yeah.
Thank you so much for the answer, Professor.
Thank you.
Okay, thank you so much for Professor Terada for answering all the questions from our students. I think the session is quite really interesting, and all the students excited about how your research has been done and also the result as well. And also from your session, I hope all the participants in here can gain a lot of information and knowledge. At last, I would like to say thank you to Prof. Terada for joining us in this webinar session. I hope maybe in the next future we can meet at person, maybe like having you in Indonesia, or maybe we can join in Japan.
Yeah.
And
yeah.
And for the last, I would like to say thank you as well to all the participants that joining us from this morning. Thank you for your attention and also participation. And I would like to say sorry if I did a mistake for conducting this session for webinar today. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone.
Okay, thank you to Professor Tsutomu Terada for the lecture. Hopefully, the lecture will help us to understand more about wearable sensing application. And I would also like to thank Professor Dr. Muhammad Yassin and lecturers from Biomedical Engineering Universitas Airlangga for your time and attendance in this webinar, and also for Mr. Alfian for conducting the 2 sessions for today's webinars. And also thank you for all participants and for your attention and enthusiasm. Thank you for Professor Dr. Kahar Osman and Professor Dr. Tsutomu Terada. Hopefully, the materials from today's lectures will be very useful for us and give us a lot more information and insight regarding the topics. And I hope I'll see you on the next webinars. Oh, and I would also like to remind you to fill the attendance form that I will send in the chat box. See you. Thank you very much, Dr. Raja. Thank you. Yeah, thank you very much, all.